Hello there, I'm Jimmy Vegas and welcome to the Beginner's Guide to Unity 6. This video tutorial series will guide you through everything you need to know to be able to use Unity 6, and I'll even provide you with all the scripts and the assets for free in each video if we use any. Remember to subscribe and click the notification bell to stay up to date with every tutorial I upload. Feel free to leave a comment and drop a like. I also have a Patreon page where you can help be a part of this channel, and you'll also find all the scripts and the assets to this series there too, along with plenty of other things. You can also now join as a free member. The game we'll be building here won't be anything specific, but we'll be exploring plenty of methods to making a game, and we'll have something playable at the end. We'll be making this game for free and will cost you absolutely nothing as long as you put your mind to it. So, who is this tutorial aimed at? Well, it's going to be aimed at newcomers to the game development world who have perhaps just picked up Unity 6 or are looking to get started with a game engine but don't know if Unity 6 is right for them just yet. I will take you from a beginner level to an intermediate level by the end. As you probably guessed, we'll be using version 6 of Unity, but this series will work for any version of Unity, so some things may be labelled slightly differently, but all of my tutorial series are built to be future-proof as well as legacy-proof. So this first segment we'll explore how to get Unity on your PC, we'll explore the hub, and we'll get acquainted with the engine interface. What is Unity in and of itself? It's an engine that you can basically import anything into, write some scripts, create a few things, and you can have a game by the end. It's a great versatile engine and is much like other engines out there. Obviously it has a few different quirks to itself. How do we get Unity on our PC? It's actually very simple. You just need to go to unity.com/download, and here you'll see a download button which will download something called the Unity Hub, which is this. I'm offline at the moment, but that's okay. You can use Unity offline. You need to log in every 30 days just for a check-in, but you can still use it offline. This is the hub. The hub is a place where you can store all of your projects, and you can see all the projects that I currently have right here. Most of these relate to my tutorials on my channel. The next section down is installs. This section is where you can install different versions of Unity. You're not restricted to just having one version, you can have multiple. At the moment on this machine that I'm using, you can see I currently have Unity 6 installed as well as an earlier version here. You can use earlier versions at any point. How do we get Unity 6 on our machine from the hub? Very easy. All we need to do is at the top we need to click Install Editor. And you can see that there is an option for long-term support. I would always recommend installing any LTS versions. LTS, long-term support. At the moment you can see version 6 is in long-term support. Same with 2022 and 2021. There are other versions that you can install if you want to, but I wouldn't recommend them at this point. As this series is aimed at Unity 6, we would just need to click Install here, and it will then install the engine itself. It may take a few minutes, so while it's installing, you may want to go and get yourself a hot beverage, a snack, and get ready for when the engine is installed. There are some other things within the Unity Hub, but these aren't relevant to actually learning Unity 6 itself. So, we have Unity 6 installed. How do we create a project? Well, let's go back to Project, and we can click on New Project at the top. If you have multiple versions of Unity installed, you can select the editor version up here. You would select 6, and then you can select any one of these pipelines. A pipeline is a way of Unity being able to create something. For a starter in Unity, the most common pipeline is to use the Universal 3D pipeline. This is the most easy and versatile way of creating your first game, or perhaps any game within Unity. There are other pipelines you can use a little later on in development, such as the High Definition Render pipeline, or High Definition 3D as it's labelled here. All you would need to do is select your project name. It can be anything you want. Then you select your location right here. If you are connected to the internet at the time of doing this, you can select your organization, which is just basically your account. You can also connect it to the cloud, and you can use version control if you want to. These are not mandatory. You can use them, but again, it's whether you understand whether you need to or not. Personally, for this project, I am not going to use the cloud or version control because I do not need to at this point. Next thing you would do is click Create Project. After a couple of minutes, you'll be presented with this screen that we saw at the beginning of the tutorial. This is the Unity engine. This is Unity 6. If you've used a game engine before, you may recognise a lot of this on your screen, i.e. its interface, how it's laid out, and what some things mean. However, if you are brand new to Unity 6, like I would expect you to be at this point, let's go through some of these tabs and windows and understand what they are and why they are relevant. Here on the left, we'll start with the hierarchy. The hierarchy is a place that you can visibly see what objects you have in your game. For example, by default we have a main camera and a directional light. They reflect whatever is in the scene view. The scene view is where you build your game visibly. So you'll see any 3D objects, 2D objects, icons, anything like that. You will see them within this window here, the scene view. The hierarchy and the scene view go hand in hand. If we were to select the main camera, we would select it in our main scene view. Same with directional light. So as I said, scene is where we can build our game. It's the easiest way of doing it. You'll notice that next to scene view, we have something called game, and it does appear like a tab. These tabs overlay one another, so you can have one selected at a time. However, we can change that if we want to. We could drag game if you hold the left mouse button and detach it, and it can be its own floating window. The game view is where we can playtest our game inside Unity 6. So let's say we built a very small level. We want to test it to make sure there are no bugs. We would play it inside the game view rather than create a whole standalone application. The tabs that we can move around can be attached anywhere. So for example, if we wanted to place the game view over here next to hierarchy, we could. So keep in mind that all of these windows can detach from the actual engine itself, become floating windows, and they can be reattached anywhere at any time. However you feel comfortable creating your game via your interface, you would just arrange it in that order. Over here on the right hand side we have something called the inspector panel. And the inspector panel is where we store information of game objects. What is a game object? Anything that we can select inside the scene view or hierarchy is known as a game object. Whether it is a model, whether it is a character, whether it is a camera, whether it is a light, it is going to appear here in your inspector panel. Every single object that you have will have at least one component. What is a component? A component are these items inside the inspector panel. So for example, we have the directional light here. That has a transform component and a light component. You can attach any component to any object, but it doesn't necessarily mean that that component is relative. For example, we could attach some physics components to a light, but that won't have any impact because a light and physics-based objects are completely different. So always try and keep your components relative to your object. Every single object will have this transform component because this dictates how big it is, where it is, which way it's facing, all that kind of thing. So we have the position here, that's where it's located in the scene. We have rotation, that is which way it's facing inside the scene. And we have scale, that is how big it is. Not every object will have a scale relative to its size. For example, let's have a crate, a wooden crate in our game. We could change the scale and make it extra large. If we change the scale on the light, it wouldn't have an impact because it is not relative. There is no size of light. You would change it in your component settings rather than your transform settings. So whenever using a game object, always keep in mind the components. They are what control everything about a game object. Down here we have the project window. And the project window is where you store all of your assets and packages. An asset can be anything at all. It can be a texture, it can be a script, it can be an animation, it can be a material, it can be a model, absolutely anything. Anything you import into your game will be an asset. And you can find them in a nice convenient folder down here. You can create more folders if you need to keep everything neat and tidy. The next tab along we have is the console tab. And this tab itself is a way of detecting where errors may occur within your game. So if you have written a piece of code incorrectly and it's not working, you press play to get into your game and it won't work, you can more than likely find where the error will occur here. And we'll create errors in the future in this series, so we can basically use the console to establish what is going on, and we can use it to its full potential. So, those are all the windows that we have by default. You may have some extra windows, you may not. However, we can add windows if we need to. So, let's say we want to add a different tab up here. We can click these three dots here, we can click on Add Tab, and then we can click on anything here. So if we wanted to add an animation, we could bring it and put it there. If we're not happy where it is, we could always bring it down here and attach it here. So now we have 3 tab windows all on top of each other with easy access. Now, there are different things that we could use and could play with around in Unity, but these are the basics. How do we manipulate things in our scene? That's the next big question. If we're going to create a game, how do we do this? Well, we can click objects inside our scene. We can use our middle mouse wheel to zoom into those objects. If you hold the middle mouse wheel, you can pan around, like so. If you hold the right mouse button, you can pan around again. Nice and easy. And that is also reflected by these tools up here. So we can use the hand, hold the left mouse button, and we can pan around on one axis, and we can still pan around 360 using the right mouse button. We can zoom out, and let's select the move tool once again. You'll notice 3 arrows do appear here. We have a green arrow, a red arrow, and a blue arrow. These represent the X, Y, and Z coordinates within a game. For example, the X is represented here with a red arrow, the Z is represented with a blue arrow, and the green arrow represents the Y. Now we can physically change these either within the scene view or over here in the position. We can set this back to 0, 0, 0. What is 0, 0, 0? 000 is dead center of your scene. What is a scene? A scene is like a level, an area, a segment of your game. So we've looked around here now and we've pretty much understood the most basic aspect of Unity 6. And at this point, you may be able to determine whether Unity 6 is right for you or whether you still need to know a little bit more. So we need to now import some assets into our game to actually make it look a little bit more like a game. How do we import? Well, it's actually very, very simple. But first, we need to ensure that our asset window down here in the project section is actually relevant to what we need. For example, if we click assets, we can see scenes. We have a scenes folder. We need to import textures, so let's create a textures folder. Right click, create folder. Call this textures. Hit return again, and you'll see this folder is empty. Let's import some textures. So if I go to a folder, select these 3 textures, and then drag and drop into Unity, it will import them as assets. I will leave a link in the pinned comment and in the description for you to click on, and you'll be able to download these textures absolutely free. Make sure you unzip them before you try importing them into Unity 6. So we now have these textures. They're not relevant too much at the moment, so let's create something to make them relevant. Let's create a ground object. So this will be an area that we will physically be able to walk on. We can go up here to Game Object, and then we can go down to 3D Object, and we can insert a cube. A cube is the simplest object that you can use inside Unity. You can manipulate these game objects to be relevant to what you want. For example, we want this to be a ground, so we want an area that we can walk around on. So let's manipulate this game object in the inspector panel to make it what we need it to be. Let's place it center of our scene. So 0, 0, 0 on the transform position. Next, we need to change the size. So we can change the scale. The scale represents the size. Let's have this as 20 by 20. So on the X, let's set this to 20, and on the Y, let's also set that to 20. let's change our camera view a little bit so we can see inside a bit better. Let's zoom out. So right now it does look like a huge tile. And we can use that to our advantage now. This is the object that we want to attach our materials onto and our textures. So we don't have materials at the moment. However, we can auto-generate one by dragging and dropping textures. So let's take this ground texture and drag and drop onto this cube. You'll see, nice and easy, that it does indeed appear on there. And in the meantime, you'll see a materials folder has been created. What can we do now? Well, let's actually rename this object to something more relevant rather than cube. So we can go to cube here in the hierarchy, press F2 or right click and rename, and let's call this ground. Next, let's make this look a little more like a ground rather than just a shiny surface with a texture on. If we zoom in, we can see, yes, although the texture looks okay, it looks a bit shiny. It doesn't look too much like a gravelly ground. How do we change this? Well, we can create something called a normal map. A normal map is a way of adding some slight 3D visibility to any texture. So if we take our ground here, hold Control on your keyboard and press D, it will create a duplicate of that ground. Next, over here in your inspector panel, you'll see a lot of different options to change and manipulate this ground 1 texture. Let's change that texture type from default to one of these. Let's change it to normal map, as that's what we're creating. If you select it, keep the texture shape as 2D, and then click on Create from Grayscale. And what this will do is it will give you the opportunity to evolve its bumpiness or its 3D visibility on the screen. Let's keep it at 0.25 and let's not worry too much about any of these other options just for now. We're just looking at the basics to Unity 6 to get something easily playable. All we need to do now is click Apply. It will change this texture to a 3D purple blue type texture. This now indicates that this particular texture can be applied to a material to give it a 3D effect. How do we do that? Well, if we go to our materials folder, just here, you'll see that we now have this little orb here, and this represents a material. Just so we understand, a texture is never applied to a game object. A texture is applied to a material, and then that material is applied to a game object. So when we dragged and dropped our texture onto this game object here, the texture didn't go on it. Unity knew what we were trying to do, and it automatically created a material. It applied the texture to that material, and then applied that material to this game object right here. That's the beauty of some things with Unity. It knows what we're trying to do, so it preempts itself. So let's click on this ground material here, and you'll see a couple of different options inside this inspector panel. We can change a couple of different options here. We can change the colouring. For example, if we were to keep it pure white, it would just be the standard colour. However, if we change it to black, you wouldn't see anything. So keep in mind that the white and black represent not being able to see it and being able to see it fully. You can add a tint to it if you wanted to. So if we selected yellow from our ring and added a yellow variant, it would give it a yellow hue. I'm going to keep it as white. So I'm going to hold Control and press Z to undo that action. Next, we can change the metallicness of it so you can see how it would impact just by changing. Same with the smoothness. The smoother it is, the more you'll have light bouncing off it in certain points, as you can see here. I'm going to hold Control and press Z to undo. You can also change the source. This is not too relevant for us at the moment. However, let's keep it as albedo alpha for now. This relates to this right here. What is this right here? This is where our texture sits. So the texture that we dragged and dropped onto here, Unity automatically put it here for us and put the material on this object. How do we make it give it that 3D bumpy look? Well, we just need to make sure we're still clicked on our ground material, click on textures, and then drag and drop this ground one onto this little square here for normal map. like so. Now what we can do is play around more with the settings to give it more of a look that would make sense. At the moment, it is too intense for what we're trying to do. So we could change the normal map back to 0 to have it basically removed, but then set it to 0.25. And you'd see if we zoom out, it has now got a bit more of a shiny, bumpy, dirty look. So already this is looking more like you would see in a decent looking game. That now brings us back to changing the source from albedo alpha to metallic alpha. And you can see just by changing that one option how much of a difference this now has on our object. If we were to set our normal map back to 1, you would see that gritty look again. So my recommendation at this point is to play around with these options here from albedo down to normal map to get an object looking exactly how you would like it. Not every object will require the same settings. For example, if we were to set the metallicness higher, smoothness a bit lower, it would look somewhat like that. And I think that looks okay for now. Let's explore what we can do with other objects and other textures. Let's take this brickwork for example. How do we manipulate an object to have this brickwork looking nice? Well, let's go to Game Object again. Let's go to 3D Object and let's go to Cube once again. Let's set the position back to 0, 0, 0, which is dead center of our scene. And now what we'll do is let's hold Control on our keyboard and let's drag this out of the ground. And you'll see that it is moved by one whole block. We've been able to snap that, and now there should be no gap between this cube and the ground. But what can we do? It's a cube. Well, we could always do what we did before and drag and drop the texture onto this object, or we could create a material a different way. Let's go to Materials, let's go to Ground, hold Control, press D, and let's rename that to Brick. Now what we can do is let's change this our own way. Let's go to the albedo here. Let's select the little button next to it. Let's find brick and let's attach it. So we can select it right there. Let's close. And now let's drag that material onto the cube we just created. Like so. Let's rename this to brick. Let's change the size as well. Let's have this as, let's have it as 4 on the X and 4 on the Y. Let's turn our camera around this way using the mouse purely. Now, you can see right now that this brick looks okay. It looks a bit intense because that's got the wrong normal map on. How do we fix that? Well, let's go to our textures right here. Let's go to brick. Hold Control and press D to duplicate and do what we did before with ground. So we can change the texture type to normal map, click Create from Grayscale, and then click on Apply at the bottom. And we just need to attach that normal map to our bricks. So let's go to Materials, let's go to Brick, and then let's select this button here, and then let's select Brick. Now let's play around with this a little bit more. Let's change it to albedo alpha. Let's decrease the metallicness of it and decrease the smoothness just a little. And let's add the normal map to be 0.5. Now those bricks look dirty, gritty and quite nasty. And I think that looks good for what we're trying to do here. So let's now drag this brick out of the ground. So hold Control and move it upwards. Let's change the scale to be 5 by 5, and let's move it to the edge of our area. So hold Control again and drag this way. Now what we can do is bring it this way, and let's hold Control and press D while we have brick selected here. That's created brick 1. Nothing has changed in the scene. However, if we drag and drop this way, we can see it's now been duplicated and we've started to get a brick wall. So at this point, we've learned how we can use textures and materials to create things inside our game. And indeed, already, if I hold Control, press D again to duplicate, we can create another one. we can already see that things are starting to take shape here. We've already created an area that looks okay for what we're trying to do, but there's so much more that we can do. So, prefabs. Prefabs are a way of storing information in a singular game object. What do I mean by that? Well, these bricks that we have laid out here can easily be manipulated to be a single game object in our project window down here. For convenience, it means that we can drag and drop all 3 of these bricks in one single go. How do we do that? Very simple. We need to create an empty game object to contain the information. So if we go to Game Object and click on Create Empty, let's call this Brick Wall. The next thing to do would be to center it in the correct position. For example, at the moment our brick wall is here. We can theoretically create the prefab as it stands now, however we want this to be as relative and normal as possible. So what we'll do is we'll attach this empty game object called brick wall into this middle object for our bricks. And we can do that by dragging and dropping on the hierarchy. Now what we've done here is create a parent and child situation. Whenever you couple things in the hierarchy, they become parent and child. For example, brick wall is now a child object of brick 1. If we were to do it the other way around, which we will do shortly, it would become a child object of brick wall. So next, let's put this as 0, 0, 0. And what this will do is rather than put the object at the center of the scene, it will put it at the center of whatever the parent object is. In this case, it's put it in the center of brick 1. Next, let's drag and drop brick wall out of brick 1 and let's place it here below ground. It's now become its own separate object again. Next, let's take brick, hold control, select brick 1, hold control again and select brick 2, and let's drag and drop these into brick wall. And it will place all 3 inside brick wall. This is now the parent object, and you can see the blue outline here represents everything that is encompassed inside itself, i.e. brick, brick 1, brick 2. It means we can still move these objects like so if we wanted to. I'm going to hold control, press Z to undo. But it does also mean that if we move the brick wall, which is the parent object, it moves all 3 at once. Hold control, press Z to undo. This is not quite a prefab just yet. It's a collection of game objects. So let's go to our asset folder here. Let's right click, create, folder. Let's call this prefabs. Let's go into the prefabs folder. And now let's drag and drop brick wall into the project window. So far we've only dragged things out of project window. The only things we've dragged in is assets from a folder. Well, you can actually drag things from the hierarchy into the project folder to create an asset. So let's drag and drop brick wall and you'll notice a color change as we do. This is now turned blue. This means that this itself is now a prefab that links to this prefab itself down here. And if we click the arrow next to brick wall, it means that this brick wall right here is all 3 of those game objects. And what we can do is we can take this brick wall here, drag and drop it into Unity right there. Let's set the 0 position. And now let's rotate it by 90 degrees on the Y. There we go. So now we've got this situation where we have a possible corner. So let's take this. Let's hold control and move up on the Y and move across on the Z and move this way. Now we have what looks like a segment. I guess it looks a bit like a prison wall, doesn't it? But we can easily change and manipulate so many things using prefabs inside Unity. And it's not just walls that you could do it with. You could theoretically do it with this ground here. So I'm going to show you just how quickly you could create something like this. So I'm going to take ground, hold control, press D. I'm going to shift it over here. Hold control, press D again, shift it down here. Hold control, press D again, shift it across. And now I'm going to select ground, 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 and game object, create empty. We'll have this as ground, and let's take those and place them inside ground, and then let's drag and drop ground into prefabs, and we now have a ground prefab. That is huge. Naturally, there is different ways of doing things like this. You could make the object larger, and you could use some tiling on the materials. However, we're not going to do that. I do that in other tutorials when they are relevant to what we're trying to do. At this point, we're happy that we have just created a prefab right here. So we also want to talk about game objects. So at this point, we've only imported textures. Let's try importing something else. Let's go to Assets. Let's right click, create a new empty folder, and let's call it something simple like Objects. And let's go into this Objects folder. And I'm going to drag and drop these two folders into Unity. As with the last one, you can go to the pinned comment or the description, and there will be a link in there where you can go and download these for free. Cost you absolutely nothing. Just remember to unzip them before you try importing them into Unity 6. Now, hopefully, when you import this, you should get this down here. So the reason you've got this is Unity itself sees the objects you're trying to import as a possible problem, but they're not. So if you go to console, you should see a couple of things here. Now, I've specifically chosen these two models so we can talk about the console in this particular part. Now, what this is referring to is the models were built in 3D Studio Max, and it cannot find the representative files within the folders that we've imported. That doesn't matter because this isn't 3D Studio Max. We're not going to manipulate those. So that error, although looks serious, doesn't matter at all. We also have a couple of FBX warnings and mesh warnings. Basically, this is Unity saying that it can't find some things, so you're going to have to maybe recreate them yourself in Unity, but that's fine. If these errors appear, you just need to click on Clear. They don't affect the playability of our game at all. So back on Project and go to Objects, and let's take a look at this fence. If we go into that folder, we can see a couple of different objects. They have their own textures right here, and we have these two right here. These are also prefabs. So a game object and a prefab are very, very similar to each other. These are game objects that have been coupled inside 3D Studio Max or any other 3D development software. Generally in Unity and game objects, you don't create them in Unity. You create them in something like Blender, Maya, 3D Studio Max, and you would import those game objects into Unity. That is how it all works. So if we were to drag and drop this game object into our scene, we'd be able to see it looks rather small. If we zoom in, we can see it's incredibly small. Its scale is not relative to the size of our game. However, we can change that. Remember over here where we have the transform component? Well, let's set it back to the center of our scene so we get a good visibility of it. And let's increase the scale. Let's have this as 100 by 100 by 100. And this is a great way of showing that it doesn't matter what size objects actually are because they are manipulated inside Unity. You could make very, very small objects inside your 3D modeling studio and increase the size in Unity. Now, ultimately, this is good for larger game projects because the actual model size itself, in terms of megabytes, would be smaller than having a fence the size it is here. So what can we do with this particular fence? Well, we can take a look at it here and scroll down. You'll notice we have the material unobtainable. So some objects you can manipulate quite easily, and there's a lot of things you can and can't do inside Unity depending on what your settings are like. I'm going to just turn the camera this way for now and just bring our fence upwards. I'm then going to let go of control and just gently bring it down to there. Next, let's take a look at the other game object. Now you'll notice this one in particular has a different layout inside of the folder, and we can drag and drop this here. And this one is oversized. So these two assets that we've imported are intentional to kind of show a point of this particular video. If we scroll down to here and click the arrow, you'll notice that we have plane and tube. If we double click tube, you'll notice that there is the asset itself. When bringing this particular asset into Unity, or when it's been created inside a 3D development studio, it has left this ground plane. Now, if we try pressing delete, we can get rid of it. If we double click on bridge again, it looks a bit more relative to the size of what we're doing here. If we double click ground, you'll see the bridge is still far too big. So let's change the size. So rather than have 100 by 100 by 100 like we did with the fence, we can change this to 0.1, 0.1 and 0.1. It still looks quite large. However, we can now set the position to 0, 0, 0. And let's drag this across this way. We can zoom in a little. Let's bring it down to match roughly with the ground and bring it this way. And now we can see that things look a bit more relative to what we're doing. So as mentioned, this particular object, we can already see that there is a shadow here. However, the lighting in the scene isn't quite adequate. Now, we spoke about this directional light a little earlier in this video series, and if we zoom out, we can see that it does indeed look like it's pointing a certain way. Now, if we drag and drop this all the way up here, nothing will change. If we try moving our light source this way, nothing will change. Everything with a directional light is controlled over here using these parameters in transform and these parameters in the light. What we could do is we could change the rotation on the X, and you'll notice that things in the scene start changing already. We can see some shadows, and we can see what we have put on the textures also change relative to whatever the light is pointing towards. So for example, this ground at the moment, although it looks the way it does, if we were to continue rotating, it would look very, very different. The way we have the texture set up for this particular ground section is very important, depending on time of day. You can also rotate different ways, like that, and we can see just how much the fence shadow is impacted. Same with the wall. The Z is not going to do a whole lot just because it's kind of spinning around. It's relative to X and Y mostly at this point. We can change the colour of the lighting, so if you wanted it bright white, you could. If you wanted it dark and dismal at any point, you could. If you wanted a bright pink hue, you absolutely could do that. So if you're in some kind of creepy dungeon, that fits quite perfect. I'm going to set it back to its original orangey, yellowy kind of colour, just to give it a more pleasant light. You could change the intensity, make it very intense. And you can also change the indirect multiplier, which isn't going to be relative at the moment, but it would be further on in development. The shadow type can be changed to no shadows, hard shadows, or soft shadows. Naturally, it would change to no shadows. You wouldn't see any shadows at all. This is relevant with some light sources, depending on what type of game you're making and what the light is. Hard shadows would basically mean it's more solid lines for your shadows. I'm going to set it back to soft shadows. There are further options that you can select. They're not too important. The only one I probably would point out is the render mode, changing from auto to important. Keep in mind though, when using light sources within Unity 6, you may end up pulling more resources, which could basically reduce your frame rate. So try not to have too much lighting going on or complex lighting. There are things that you can do to change how it looks without lighting or too many light sources. But there are other light sources that we could explore. So what I'm going to do is I'm going to turn off this directional light. And to do that, I can go over here to the inspector panel and untick this. It means our scene is completely dark. We can't see anything because there's no real light source. How do we add other light sources? Well, let's go to Game Object. And we can go down to light, and you can see that we have the option for directional light, point light, spotlight, and area light. There are some probes that we can use, however, we'll just stick to lighting at the moment. Let's go with point light. Now, you should be able to see that after selecting this, there is a slight bit of light in our scene. Point lights are more useful when it comes to refined areas. For example, if you have a mansion, like in Resident Evil, you wouldn't specifically use a directional light. A directional light is used more for outside purposes. A point light and a spotlight, which we'll get to in a moment, are more appropriate for inside environments. Now, what this means is that we can change the range to whatever you want it to. And you can see that it is starting to have an impact on how the scene looks, similar to how the directional light was working. The colour can also be changed. Again, if you want to give it that slight hue, you can. This mode here, real time, which we didn't really touch on when it came to the directional light, but I will explain now what the mode is. You can have real time, mixed, or baked. The idea of real time means that everything inside the game is live. It's happening real time in terms of the lighting. If you have a light source that never needs to change, nothing relies on it per se, you can bake it. And what that means is it sets how the game will look with that lighting that you have set. This can ultimately save resources in the long run. We can change the intensity if we want. Obviously, same principles as when we had the directional light. And again, with the indirect multiplier, it's not too relevant right now. However, you may want to set shadows back on, so we have soft shadows. Let's set our intensity back to 1, and let's move our light source around. And you can see that this time, moving the light source does indeed have an impact on what the game looks like. Like with the directional light, it emits the light, but the way you change the position and where the light source comes from is different depending on that light source. Next, let's check out the light next down, which is spotlight. And this one can be used to basically put a focus on something. If I move it up and down, you should be able to see this circle here represents where the light is. And we can change the range so it goes further. We can change the intensity so it's brighter. Same with the colour, we can change it, maybe give it a bit of a red look on there. And you can change the spot angle. This will make it very thin or very large depending on what kind of area you want to illuminate. You can use all three light sources in conjunction with one another. So for example, if we were to turn the directional light back on, you would still see the light from the spotlight and the point light. The point light, not so much, but that doesn't matter too much because you could always just turn that off. There we go. So what can we ultimately do with a lot of these light sources? You know, how do they make things look better? Well, do you remember when we applied the normal maps to these objects here? Well, obviously a normal map can have a big impact on how an object will look. A good example of this is our bridge right here. So what we'll do is let's turn our directional light off and let's keep our point light off and let's move our spotlight to cover the bridge. Let's move it this way. If I can grab hold of it. There we go. So I'm going to put it in the middle of the bridge. Let's lift it upwards so we cover the bridge a little bit more. And let's make our range a bit further. And let's change the spot angle to be a little bit more covering the bridge. I'm going to change it to a yellowy kind of colour. Very, very slight yellow. And at the moment, this bridge just doesn't quite look right. Something doesn't quite look right with it. That comes down to the object itself. So what we'll do is let's right click on the bridge. And you'll notice down here you have an option for prefab. Near the bottom you should have unpack completely. So let's press unpack completely. Next we can click on tube. And you'll notice that this particular game object has the material that we can't necessarily change. You can work on this in different ways if you wanted to. You could add other textures to it if you wanted. For example, if we drag and drop this bridge texture onto our bridge, it works for us and we're now able to manipulate that material. So this kind of comes back to the last time when we spoke about prefabs and game objects. Depending on what the object is, you may need to just change a couple of things. In this instance, it didn't have a material, it was already attached to the object, and we want to be able to modify that material, so we can just create a new one by adding the texture to it. So what we can do now is go here, go to the material down here, and let's drag and drop the normal map onto it. And you can now see that the lighting has made this bridge look a bit grittier, like it's a little bit wet. And this is where you can work in conjunction with prefabs and game objects and materials and textures with the lighting and the shadows to make them look kind of cool. It just depends how far you want to take it. So the recommendation that I will give you is work with a lot of these pieces and make something look really, really cool. Now, I like how that's kind of looking wet and dirty and gritty, but not quite the normal map. You may get an error here that says this texture is not marked as normal map. If you click Fix Now, it will just fix the error automatically in Unity. Again, this is Unity detecting something that it thinks probably should be the case, and most of the time it works nicely. So setting this to 0 means basically it looks how it did before. A bit flat, a bit boring, whether we have the light on it or not. However, changing it to 0.5, maybe a bit more, let's do 0.75, gives it that extra 3D kind of gritty look of it, combined with the lighting, makes it look really, really cool. And this is how a lot of game developers will at least start making a game that looks okay, but they can work with the lighting to make it even better. Let's turn our directional light back on. However, let's put the intensity down a little bit. Let's have this as 0.5. And let's have our point light on. And to be honest, I think that looks kind of cool. Best thing that you can do at this point is to work with the light and the shadows to get things looking how you would want them to look. For example, if we go back to the ground and go to the materials folder, we can change that ground. Let's have them a normal map as 0.5, a bit more metallic and a bit less smooth. And now that looks kind of cool. So already at this point, we actually have a decent game kind of in place. And never be afraid to move things around like so, like moving the light sources around to see if you can perfect how things would look. Because lighting and shadows are incredibly important when it comes to game development. So, how do we get physics in this game? Well, there is something that you may have noticed already. Whenever we have an object clicked, you'll notice these green lines. I haven't talked about them at the moment. However, these green lines represent some kind of physics. These are known as colliders. What is a collider? It means something can or cannot pass through something. It means something can land on something. It can mean something is also a trigger. So physics can be used in many different ways, not just to stop people walking through objects or to stop people falling through the ground. So a good example of that is you could use physics to collect an object. And I know that sounds a bit strange at the moment, but it is something that we'll cover a little later on. So let's put in an example of physics and gravity. What I'm going to do is I'm going to create an object that is basically just a ball. So let's go to Game Object, and let's go to 3D Object, and let's go to Sphere. Let's put this in the center of our scene. And let's drag it upwards, and let's bring it across so we can see it a bit better somewhere around here. At the moment, it doesn't look too impressive, so let's quickly add some texture to it. I'm just going to drag and drop this stone texture, and it'll do just fine. If you want to add a normal map to it, that's absolutely up to you. But this one is more about what the ball will do. So, something we haven't done at the moment is explore the camera and the game view. And we're going to do that now so we can physically see something happening in this game. If we go to the main camera, and you'll notice these lines here, they all point outwards. This is what the game view can see. If you click the game tab, you can see that's what will be rendered. So let's drag our camera this way, all the way back to where our bridge is, roughly. Press the game view again, and you can see that's where our ball is. If we were to press play, nothing would happen at all, because nothing is inside the game that can do anything. It would just be rendering what we've built. So how do we make it so as this ball actually does something? Well, again, this is where we can insert gravity and relate it to the physics in the game. This requires a component to be added. So if we click on our sphere, scroll down on our inspector panel and click on Add Component, this is where you can see all the different components that can be added. Now we're dealing with physics, so we need to click on Physics, and we need to add gravity, or the ability for this particular object to use a gravitational force. And to do that, we use this thing right here called rigid body. So if we click it, you'll see a couple of different options, and we'll change some of these. But what I want to do is I want to press play. So although we've applied the rigid body, you can see that there is some kind of physics now going on. This sphere actually moved. It's being affected by gravity. However, if we try dragging our sphere over here to our bridge, just making sure that it is over the bridge, so we'll place it just here. Let's take our camera and let's turn it 180 degrees. So we're actually looking at the bridge. Click Game View, we can see it. In fact, let's drag our camera up a little bit so we can see a bit better. There we go. So what happens when our sphere that has the gravitational force attached in a rigid body, what happens when it hits the bridge? We saw when it hit the ground, it stopped, but it just goes through our bridge. You have to remember that not everything in your game when you import it will be set up to correctly determine physics. In this case, our bridge, you probably can't see any green outline around it. That means there is no collider on there. So what we'll do is we'll go to Tube 01, which is our bridge, and we will scroll down. Let's go to Add Component, and then let's go to Physics, and we'll click Box Collider. So let's talk about colliders. Colliders come in different forms. The main and simplest one would be a box collider. Something like a mesh collider can also be used. Now, what is the difference between a mesh collider and a box collider? Well, if we scroll down and go to Add Component, go to Physics once again, and click on Mesh Collider just here, and let's turn off Box Collider, and then let's tick Convex in the Mesh Collider, you'll notice that a lot of those lines are all over the place. Now, something like this means that a Mesh Collider is attempting to seek out every angle of the object and put a collider on it. Sometimes it will work, sometimes it won't. It's not really relative to us at the moment to have a mesh collider because it's not going to work the exact way we want it to. Also, in the long run, it could use up far more resources than is necessary. So when it comes to most objects, you probably don't need a mesh collider for the physics. You just need a box collider. A good example would be a chair. If you have a chair in your scene, you don't need a mesh collider to do every angle of the chair. All you would need is a box collider around that chair to stop the character from being able to walk through it. You would also save many resources. So let's remove this mesh collider component. Let's right click and we can remove component. Let's retick box collider and let's take a look. Is this box collider exactly right? Well, if we zoom in and take a look, no, not quite, because we want this bit to be walkable. However, it's saying that the collision is just above it. And we can use this to our advantage because we can change the position or the center or the size of the actual collider itself. For example, if we change this center, hold your mouse over Y, hold the left mouse button down and move it up and down, and you'll notice that this collision now changes. So we could have that like so. If we set this as 2.5, you could do it manually that way. Now, if we press play, we'll be able to see that this game object, the sphere, will land on the bridge. Perfect. So what it basically means is that you need to determine in your game what counts and what doesn't count as correct physics. For example, if we take our sphere, let's move it all the way this way to the end of our bridge. Let's rotate our bridge. Let's change the rotation on the X so it kind of should make the ball roll basically. And what we'll do is we'll bring it upwards to about there. Oh, a bit more actually, I think, because I want the sphere to basically roll onto this bit right here. So let's bring the sphere up a little bit more to there. Let's press play and let's see what happens. So naturally, it lands on the bridge and starts rolling down the bridge. This is the power of the rigid body. So all of this motion that's happening is all because of the rigid body. And as I said, there are different options that you can change in here, and changing some of these things will have a dramatic impact on what's happening with your particular game object. For example, if we were to constrain it, if we freeze the position or freeze the rotation, it wouldn't quite look right. Let's put that to the test. Let's change the freeze rotation to all be true. What this means is that everything will still be applied apart from the rotation. So the ball will still fall, it'll still move down, but it won't actually rotate. So it looks a bit odd, if you get what I mean. So be mindful of a lot of these options that don't necessarily need to exist. For example, if we change the mass to 1000 and press play, in our scene view, it's not really relative, because at the end of the day, the mass of this is not 1000. It's irrelevant to what we're trying to do. You could change the drag, the angular drag, and you'll see some dramatic effects depending on the game object. So in this case, there is a lot more drag on there. There's no need for the drag to exist. So the whole thing still functions as you would expect, but the drag is what changes the physics. So if we wanted standard physics, I'd say that's just fine. That's not a problem at all. When it comes to this fence over here, if we zoom into it, and let's go to the fence object, which is that one there, again, there is no actual collider on it. So we could theoretically add a collider. And now, if we had a player, the player would not be able to walk through this unless we set up that player to be whatever they were trying to do. Other things you could do is, not that it's really relevant at this point, but if we wanted to duplicate our fence, drag it upwards to, let's say there, maybe change the rotation a little bit, let's say 32, 41, 5 or something like that. And then let's add a rigid body to it. There is a different way you could add it. Let's say you don't know where to look for something, but you know what you want. So you could type in here and say rigid body, and it would appear easy. Let's change our camera to face the other way once again, set it back to 0. Click on game view to make sure our fence is there. And let's press play to see what would happen with the fence. It should fall and land flat. Perfect. So what this means is that creating the correct environment for all of your physics is important. Now, if we put this fence back to, let's say, 0, 0, 0 on rotation, and let me bring the camera down just a little bit so we can see the end result, the physics won't quite function as you would hope. So let's press play. And it just ends up like that. So what you've got to be very mindful of is, if in this case of this piece of wood, what if we removed the box collider? Let's go back to our scene view and just pan our camera around a little bit, and went to add component, and we wanted to add a mesh collider, and then click on convex. We may end up with a slightly different result now. If we press play, we should see our fence fall to the ground and do that. So remember earlier when I was saying that some things would need to have a mesh collider? This is a perfect example of where physics shows that the appropriate collider is not a box collider in that case. It's the appropriate collider for physics in this fence, but it is not the appropriate one for the fence falling down. If we were to take multiple fences, so hold Control, press D, let's move a couple around a little bit, just to kind of illustrate things. They all not interact with each other, but they are somewhat relevant to each other's existence. So if we press play now, all 4 fences will fall, they'll do roughly the same thing, but you'll notice that here, for example, this one now falls on top of the other one. Perfect. Although we're using mesh colliders here, I wouldn't worry too much about it impacting your performance of your game. The problem with mesh colliders is using far too many unnecessarily. If an object is necessary for a mesh collider, then yes, use it. If it's unnecessary, don't use it. And what it all comes down to, I think, really, is just how you want your game to be. Like if we, let's say we duplicate this fence. This one here, sorry. There we go, got the right one. Duplicate it multiple times. This object now exists within itself. And what you could end up seeing are some very odd effects. And hopefully it will work when we do it. There we go. So what's happened there is the object itself has detected inside its collider is other objects that shouldn't be there. And they kind of push each other away. And I think I want to bring the camera backwards a little bit to kind of illustrate just how that physics works. So if I bring it back, there we go, and press play now, let's see what happens to these fences. You can see that they push themselves away. And that all comes down to two things. As I've said, it's the rigid body that's attached, and it is the collider that we have attached as well. So when it comes down to gravity and physics, having those two hand in hand is what really, really counts to getting things working correctly. Animation is a key feature of any game of this caliber. And most animations that you see in the game aren't created in the engine itself. For example, if you have an NPC that walks around, the animation will more than likely be created in the 3D modeling program rather than Unity itself. But that doesn't mean to say that you can't create animations in Unity, because you can. A lot of the time, you can just create simple animations that take a couple of minutes to set up and get working. Other times they can take a bit longer to tweak, depending on what you're doing. So the idea of what I want to create in this section is this object here that we have as the fence. I want this to open and then close as if it were like a gate. Now to do that, I need to set up a couple of different things. I need to set up an object that can be animated and then clip the actual fence to it, so that animation drags other parts with it, so it gives the impression of an opening and closing gate. To do that, let's actually change this a little bit. Let's make sure we have a bit of a fence going on. So what I'm going to do is I'm going to hold Control, press D to duplicate it, bring it outwards to about there, and I'm going to hold Control, press D to duplicate once again. And let's use a feature that we've used in a previous tutorial, which is prefabs. So let's create a prefab. Create empty, and let's call it fence. And then we select both of those, drag them into fence, and then drag fence into our prefab folder. And now we can drag and drop that prefab over here and place it roughly where we need it to be. Again, a lot of game design when it comes to these kind of tutorials is more, you're shown how to do things, you take the time to do things a little better. Next thing we need to do is set up this bit of the fence, which is going to be our gate. To do that, we're going to create a cube which we're going to animate, and you'll see just how this kind of works, as in you animate an object and you can clip and attach objects to that object to create further animation. So in order to do that, let's go to Game Object, let's go to 3D Object, and let's go to Cube. Let's bring this cube to be roughly in line with the pivot point of this gate. So the gate is going to be roughly round about there. A quicker way of doing it, rather than trying to get it exactly right, would be to take your cube, attach it to the object you want to animate, and then zero out the position. And we should be able to see that looks just fine. So now, uncouple this cube from your fence. So let's drag it to there. And then make sure we put our fence on here after we've changed the size of our cube. Let's change this to be more in line with this pivotable pole. So let's change the scale to 2 on the Y, maybe a bit more. In fact, no, we'll leave it as 2. We'll just drag that up to round about there. Let's change the scale to 0.1 on the X and 0.1 on the Z. And now we just need to move it to be perfectly in line with the pivotable pole. That might not be perfect, but it should do the trick. Let's rename this now to be gate. And then let's drag and drop this onto gate. Now, to give an early indication of what this should look like, let's take gate and let's pivot it. So you can change it on the Y, like so, and it will open and close the gate. So although it works just fine, we now need to find a way to make that animation work. But before we do, let's turn off Mesh Renderer on the gate. So it's that cube that we've just created. And what that means is that we're not able to physically see the game object anymore because it's a theoretical object. It's an imaginary object, but it serves an important function. Next, let's go to Assets. Let's right-click, create a new folder. And let's call this Animations. And let's go into this folder. Next, we need to click on our Animation tab that we added at the very start of all of this. If you didn't do it, you just need to remember, click these three buttons here, and then you can go to Add tab, and then click on Animation. And I now have two animations, but I don't need to. So I'm going to remove it by clicking Close tab. So make sure we are in our Animations folder. Make sure we're on our Gate object. Click on Animation. Now we need to create the animation file. So we can click on Create, and we'll call this Gate Swing. Now, you'll be presented with a timeline at this point, and this timeline represents every frame that could be possible inside your game. At the moment, we can't do anything. The most important thing to do once you've created your animation is to click this record button. You'll know you're in the recording phase because all of this turns red, and this has a deep red on the background. The very first thing you'll need to do after doing that is setting the very first keyframe. The keyframes are important because it means that that is the starting position of the animation. And we want the starting position of this animation to be exactly what it is now. As we're only going to be dealing with the rotation at this point, we only need to set the keyframe on the rotation. That means that if we set the Y rotation to 1 and then back to 0, you'll notice that it's turned red up here and you have some dots here. This means that that first keyframe has indeed been set. So the animation will always start with a rotation set at 0, 0, 0. Now, we want our gate to swing open over the course of, let's say, 2 seconds. And as we're working in 60 frames a second, this number here represents the frame number. So let's change this to frame 120, which is 2 seconds. Hit return. That will now take you to frame 120, 2 seconds. And we want to make sure our gate is swung open. So we will change the rotation to something like that. So in fact, I'll manually type it to 75, but obviously you take your time, you set it to whatever you would want it to be. I want the gate to now stay open for 2 seconds and then close again. So in order to do that, we need to add 120 frames. So that will be frame 240. And rather than make any other animation, all we need to do is make sure that you remove the 75 in the Y box and then retype it. And all that will do is set a keyframe to be exactly the same as the previous keyframe. And what that means is no animation will occur. Now what we need to do is close the gate over the course of 2 seconds again. So let's add another 120 frames. That'll be 360, which will be the 6th second. And by then we want this to close all the way. So we can press 0. And that will then close the gate. Now, although we've not really seen the animation, we've just set those keyframes. Trust me, when we come to the game view, this animation will work just fine. Once you've set your last keyframe for animation, all you need to do is press the record button again. That will set the animation into that file you've just created, and it means that it will now work as intended. So if we go to our project view, you'll notice that in our animations we now have 2 files. One is an animation, and the other is the controller. The controller for an animation is important, and we will talk about it a little more later on. But for now, we just need to make sure that our animation does indeed work. So I'm going to take our main camera, and I think it's a bit far away, so maybe we should zoom it in a little bit so we get a good view of our animation. Let's bring it to here. And now let's press play and watch it open and then close. And now it should close again. And it should open again. Perfect. So we have just animated this really quickly and really easily inside Unity. What you can also do is, if you don't want it to repeat, you just want it to open and close once, you need to go to the animation and then untick loop time. Press play once again, and we'll have to forgive all the falling fences, but it will open and then close, no problem at all, and it will not repeat itself. Again, if you do want it to repeat, you would just make sure loop time is ticked. So the animation works perfectly as intended. If I zoom in, and if I move the gate out to maybe there, and press play once again, it will animate in that position. Perfect. And again, the physics has an impact on whatever this is doing because there is a collider attached. So over the last, I'd say, pieces that we've done, you can really see how all of this is coming together to create the game that we want. Let's put the fence back in there. But animation, you can take animation much, much further if you wanted to. All you would need to do is, if you go to game, go to your animation, you can modify where these pieces are. Always press record first. Let's do that. Bring those keyframes to there. Press play. And it opens quicker. So you can always modify your time frame on your animation. Programming is something a lot of people always find to be the most daunting part of game development, but it's not as scary as you would think. What we'll do this time is we will create a script. We'll explore the script and we'll get the script to do something in our game. Firstly, let's create a folder specifically for scripts. So let's go to our assets down here, right click, create, folder. We'll call it scripts. And in this folder, let's then right click, create a new script. Let's call this starter script. And then let's open that up. It will open, more than likely, in Microsoft Visual Studio. And when it does, you'll notice some default lines of code are already in place. Let's go through these lines of code to understand what this script is basically doing at this point and what we're going to do to it to make it do what we want it to do. Firstly, at the very top, we have something that says using Unity Engine. Now, you have to remember that the C# language that we're programming in here is not specific to Unity. This up here is known as a namespace, and you can think of a namespace as an area of the code that can be used as like a library. So there are lines of code within this script that you'll need to know where to go to. So it refers to the namespace, so it knows that, that line means this, simply because we've stated it in the namespace. So if you were to use something perhaps like a scene manager, you would need just to declare it inside the namespace. Like I said, it's like a library. Next we have the class. Now the class name needs to be the exact same as the script name. So if we were to change the script name at any point to say starter script 4, we would also need to change the class name. Most coding that you do will be inside the class, and that's dictated here by this open curly bracket. And you'll see it goes all the way down to this close curly bracket. Whenever you code something like this, they should always be contained inside curly brackets. This way the script knows that that's this section, that's that section. Just like we have here with void start. This is known as a method. And a method inside a script is a section of code that can be run at different intervals, whether it is when the script starts, whether it is a constant, whether it's when it's called via another script, or when we do something in the game, perhaps press a button and it runs a different method. These green lines here are known as annotations. They are not lines of code, they are just notes that can mean different things. For example, like it says here, start is called once before the first execution of update after the mono behavior is created. What this means is that void start will run as soon as the game starts, and it will only run once. Update is called once per frame. That means that the update method will be run constantly. So this script will be constantly monitoring what is going on. So this script, what we're going to do is we're going to add in a couple of variables, and we're going to set those variables, and we're going to make those variables do something. So what is a variable? It is anything in the script that can be referred to something else. For example, a number is a variable. A piece of text is a variable. A game object is a variable. An audio source is a variable. And that's how the script knows that what you want to do is relative to those variables. So let's start by declaring a variable. Let's declare a whole number. So after your open curly bracket at the top, hit return, and let's type in square brackets serialize field. Now what this means is that we want whatever we are declaring here to appear inside our inspector panel. The reason we want it to appear there is we want to visibly see that what we're doing means something, that something is actually happening. You could have this as public, however that may use more resources than you would want it to in the larger scheme of things. So for now, to get it to display in our inspector panel, which you will see fairly soon, we serialize the field. After you've done that, we now need to declare the type of variable. And as I said, it's going to be a whole number. And another word for whole number is integer. And we can shorten that to just int, int, which is how we declare a whole number. So int. It will turn blue. And the next thing is something you would name it. So let's call it my number. And the way you declare a variable, there's no set actual way of doing it, but the most common way is known as camel casing, where the first letter of the first word of a variable is always lowercase and every subsequent letter is uppercase. So for example, my number. Then you would use a semicolon to close the line off. Most of the time, whenever you finish the line, it will end with a semicolon. There are other cases, for example here in the start method, where you don't need a semicolon. However, these are where it does differ a little bit. Whenever we're declaring a standard line of code like this here, it does need a semicolon. If you hit return, you'll notice this grey underneath is starting to predict what it thinks is the next thing to do. And it is indeed true. So what we can do is we can press tab and it will automatically fill that in because we want the string, which is a text, to be our next variable. Our third variable is not going to be string my description. We're actually going to create a bool. A bool can be true or false. It can only be one of those two. So once again, let's type in square brackets serialize field, and then we'll type bool, B-O-O-L, and we'll put my choice with a semicolon. And you can see that all three of these, the type is all highlighted in a nice blue colour. That kind of gives you an indication of the ordering of how all this comes together. So you serialize your field, you have your type, and then you have your name in the white. But that's not strictly true all the time. For example, you could still declare a variable without serialize field or public. You could simply put int my other number, semicolon, and you'll see this being relative a little later on in the video. So let's also have a game object as a variable. So we could actually refer to an object in our game to do something. So let's serialize field in square brackets and let's type game object. And you'll notice this is a little different. This is highlighted a different blue colour. Don't let it throw you too much. Don't worry. It's still going to be declared as a variable. However, what I do want to point out here is capitalization is important. You'll notice that I do have a capital G and a capital O. However, a lowercase g and a capital O means something different. So although they both say game object, referring to a game object with a lowercase g is different than an uppercase G. Either way, we now have the type as game object, so let's call it what we want. Let's have this called as my gate, semicolon. And obviously that's going to refer to the gate that we had previous. Now, what we'll do is let's delete the green lines here because they're the annotations and we don't really need these annotations now. So they can be deleted. And what we want to do is I want to actually save this script now. You'll notice these green lines down the side. That means that everything is saved just fine. That's what's changed since the last save. That's fine. If we head back into Unity now and add an empty game object, and let's call this script holder. And now let's take this script and let's place it on the script holder. And you'll notice over on the right, we have some values set. Now, we have 4 variables right here. However, we wrote 5 variables, didn't we? Do you remember what I said about this one here? Well, this variable exists in the script, but we can't physically see it in the inspector panel because it's not serialized and it's not public. But that's fine. It's just kind of illustrate that that's how you can still declare a variable. So back in Unity, you'll see that my number is 0, my name is nothing, my choice isn't ticked, and my gate has no game object attached to it. But if we press play, everything should still function as normal. Nothing will change within our script. So how do we make this now so as something will happen? Let's make this script do something. Okay, let's head back to the script itself. And let's start by saying, let's put my number as 4. So what we can do in void start, because we want this to happen as soon as the game starts, we'll say my number equals 4. Nice and simple. Let's make my name equals something. So we can say my name equals, and in quotes, you'll know you've done that right when they turn kind of a red colour. And I'll just put Jimmy. And then we'll say my choice equals true, which will mean that that box is being ticked. And you'll notice after every single one of these lines, I'm putting that semicolon again. And finally, what we'll say is my gate, we're going to make it visible. So the idea of what we'll do is before we actually play the game next time, we'll turn off our gate and then we'll make the script turn it back on. So we can say my gate dot set active and in brackets true with a semicolon. Now let's save that script. So all we've done at this point is say, okay, yep, we set our number to 4. My name is Jimmy. Choice is true. And we'll turn the gate on. So that means if we head back into Unity, and you may get this down here. So my name is assigned but never used. That's fine. A yellow warning inside console is never massively important. It's not game breaking. But what we will do is we need to attach our gate over here to this variable. So you can drag and drop gate onto this section right here. And what we've done there is we've now made this script realize that whenever we refer to my gate, it actually means this object right here. So if we take our game object called the gate and turn it off up here, make it disappear, the script will then be responsible for turning it back on whenever we press play. So if we go to game view, we can see it's not there. However, let's press play and we should see this gate appear and then open. Perfect, and that's all done via the script. So if we go to script holder now, we can see that those variables we set are there. It's been set to 4, my name is now Jimmy, and the choice is true. And you can take that even further depending on what you need to do. So let's say, for example, we want to say if my number is 4, then my name is Jimmy. Otherwise, it's going to be Fred. So we can do that in void start. We need to say if, and then open brackets, and we can say my number double equals 4, and then close bracket and open curly bracket and hit return. So why have we used double equals there? Well, when it comes to coding like this, equals and double equals means 2 different things. So here we're stating that it should be equal to 4. Here we're asking, is it equal to 4? So that's how we can say that Is it equal to 4? Is it equal to or less than 4? Is it not equal to 4? That kind of thing. So we can say, if it's equal to 4, then I'm going to take this line of code, I'm going to cut it out of there, just my name Jimmy, and place it in here. After that, we can say else, and then open curly bracket, and we'll say my name equals Fred with a semicolon. And naturally, let's get rid of this blank line of code. Let's save our script there. So what we've done here is whenever we start, it's going to be 4. So obviously, let's start this script now, and it will say Jimmy as my name. And it does. However, if we were to start this script with the number as 3, save it, back into Unity, let it compile just for a moment. When we start the game now, the name will come up Fred. Like so. Simply because we have put a statement in here to say if something is something, then do this. Otherwise, which is this section here, you should do this. Now the great thing about what we've done here is that this can be used in a live situation, which is where void update comes in. If we were to take these lines of code here, so from if all the way down to this closed curly bracket, and cut that out of there and place it inside update, save, head back into Unity, give it a moment just to compile. And if we press play now, the name will pop up with Fred. However, if we change this value here in the inspector panel to 4, the name changes to Jimmy. If we change it to 5, it goes back to Fred. 0, Fred. If we change it to 4, it changes to Jimmy. So you can see just how live this will be. And you can then increase whatever these if statements do. For example, if we only want the gate to appear when my name is Jimmy, we can take that line of code and place it in here. But we can then do the inverse of that and say if my name is equal to Fred, then my gate.setActive is false, and that will turn it off. So let's save that script now and quickly recap what's happening here. The script will start, game will start. We set our number to 3 and my choice to true. It means that constantly monitoring in the update method, if it's 4, then we make it say Jimmy and we put the gate on. If it says anything else, it turns the gate off and says Fred. So let's go back into Unity. Let's press play and the gate will not appear. Cool. Let's change this to 2. It still doesn't appear. Let's change it to 4. The gate appears and changes to Jimmy. But let's change this to 5. The gate disappears and the name is now Fred. Change it back to 4. The gate reappears. So in terms of coding, this is a very, very simplistic view of coding, and there is more things that you can do. Like you can nest code together and you can add things to it. So for example, if my number is equal to 4 and we'll use a double ampersand, my choice equals true, and then save. And what this means now is that the number has to be 4 and the choice has to be true. So the number can be 4, but the choice could be false and the gate still wouldn't appear. So let's try that out now. But this is a great way for me to say that whenever you code something like this, always save it, always go into Unity and check out things little by little to make sure the code works as intended. So here, like I said, so if we change this to 4, the gate appears and it changes to Jimmy because my choice is set to true. However, we can untick my choice now and it disappears. You can keep doing that on, off. Nice and easy. Perfect. And there are different ways that you can approach this as well. As I said, this is a very simplistic script and there will be more coding later on. It's just what you basically do with this kind of thing. You can create a small script and build up from there. That's always the best way to do it. Don't try going in full on script, full on trying to get it done perfectly. Build it up from the start and you can work with it. I will put this script in the pinned comment a link in there for you to download. It's in the description as well if you want to download it, put it in your game, trial it out, test it. So when people speak about the asset store, you probably make the assumption that it's a store where you buy things, but that isn't strictly true because there are plenty of free assets that you can get on the asset store. And remember when we spoke about assets, saying what they are, it means yes, all of those things that you can get on the asset store for free or paid if you wanted to, there are assets for your game. The one we want to focus on today is how do we get a player in? Now, I have made tutorials on how to create a playable character, but as this is aimed at beginners, new people to Unity 6, we're going to use some tools that Unity themselves have created to enable people like you, like me when I started, to be able to use Unity better, quicker and easier. So how do we get to these tools and how do we get to the asset store? Well, it's very simple. At the top, if you click Window, you can click on Asset Store. And what this will do is it will open up a window where you can see the asset store. You'll need to log in just to make sure you can indeed log on. And yes, I know this says Black Friday at the top, and you're probably watching this in 2025 because I've not long got around to editing all of this. But you can essentially just search for starter assets here in the search box, and you'll be presented with these options. Be sure to choose the ones, in this instance, that say Unity Technologies. These are the assets that Unity have created for you to use easily. If you wanted a third-person controller, you can have this starter assets third-person. You've got character controllers here, and down here is the first-person character, which we're going to use. So if you click on this one here, you'll be presented with this screen. And all you would need to do is click on Download or Open in Unity, this blue button right here. And what that will do is it will link to the open Unity 6 engine that you have right now, and you'll be presented with this window. This window is the Package Manager, and every account has a Package Manager. So every asset you've downloaded and is available will be within this Package Manager. All you need to do is make sure that it does indeed say starter assets first person or third person if you want to do it that way. And you just need to import it into our project. So we just click on this button right here. And I'm doing this live. I haven't pre-imported it. We can see all this. And what this is saying is that this particular asset relies on a couple of different things that we need to import into Unity. That's fine, and all it means is that it can't function correctly without having all of these on here. So I'm going to click Install and Upgrade. While that's doing that, let's talk about what else you can find on the Asset Store. It is a wonderful place, as I said, that you can search for all different kinds of assets. Some are paid, some are free. And as you scroll down here now, you can see that there are some starter assets from different creators who are happy just to put them on there for free. Or if you want to pay for different things, you can. You can pay a couple of dollars, or in my case euros, and you'll be able to download some of these assets for your game. Now, there is the term asset flip, which has existed for quite a while now, and I have done videos on what an asset flip is and what it isn't. Long story short, as long as you're not taking full asset packages and claiming it's your own game, that's not an asset flip. You could take some assets from here, some assets from here, some assets from here, from here, from here, from here, all of these different models, put your own code in there, your own sound effects, all that kind of thing, and you've created a game with the assets on the asset store. The idea of the asset store is for you to help build your game. It's there to help you. It's not there to make people think you're ripping things off, because you're not. You're actually developing a game yourself. But this one here, it looks like it probably is a full game considering the price of it. So if you took this one and just renamed it to My Super Awesome Adventure and tried selling it, that would be an asset flip. But you're obviously here because you want to learn how to develop. You're not here because you're interested in asset flipping, which is good, because that's what we're all here for, learn how to make games. So let's head back into Unity now, because it looks like we're almost there and imported. So this says, this project is using the new input system. You may get this. What we want to do is, yes, we do want to restart the editor, and this may take a little bit of time. So let's press yes, and let's have it reopen itself to do that. If it does take a while, I will simply sort it out in the edit. So as this is completed now, yes, just a quick recap on Asset Store. Never be afraid to use anything on the Asset Store. It's there to help you. There are some quality assets on there. It's updated all the time. There's always something there for any type of game to find. So go and enjoy it. Okay, so it didn't need to restart. Oh, hang on. Yes, it did. So what we'll do at this point is we will click. It's not letting us do that. So let's cancel that for now. Let's click on import. And then once that's imported, all we'll need to do is just basically save the scene that we're in. May need to restart Unity if it goes a little bit haywire. But either way, we've now imported our player as soon as this is done. I don't need the Asset Store anymore, so I could probably close that window. You can close it if you want to. But the idea of what we'll do in the next section of this particular bit is when Unity allows us, we'll put our player in and we'll look at it and see what we can and can't do. So it revolves around cameras as well. Hopefully, when this is done, it's taking a little bit longer than I would have liked, I've got to be honest. There we go. So we can now close the package manager. And let's see if we can indeed put our player in without having to restart Unity itself. So to find it, if we go to Assets, we can go to Start Assets, and then First Person View or Third Person if you have that, and then Prefabs, and we want this one here, which is the player capsule. And if we drag and drop this into our game, we've basically got a capsule that can walk around, and this is how we can control things. If we press play, I don't suspect this will work as intended, but that is completely fine. We've at least got our player in and we've spoken about what we need to. A lot of this can be cleaned up in editing really, so there's no wastage. But yeah, what we'll do is let's restart Unity to make sure everything is okay. So I'll see you on the other side. Okay, so Unity has restarted. I'm back in the game and yep, our player capsule is right here. Now, the idea of what we've got here is this character, this playable capsule, should be movable around our game now. So if we press play, once you've restarted Unity yourself, we should be able to go into the game, see the capsule, and then use WASD to move around. And we can. And this is a great opportunity already that we can see the physics having an impact on we can't pass through the fence. And that's awesome. And you can see we're walking over all of these fences here, and you can see the capsule going up and down. You can also use the arrow keys if you want to. But since this is supposed to be a first-person view, it's not really first-person at the moment. This is where we do a little bit of modification to the player capsule itself. Now, if we go to the capsule, click on the arrow, you'll see player, camera root, and capsule. This main camera that we have right here, all we need to do really is drag and drop this onto the camera root right there and zero out the position. And what that means is that we should now be able to theoretically move around with our camera. It's not going to look perfect because all we've done is just drop it on there, zero out the position, but we should get a feeling of how things are going to start looking perfect. And we can also move our mouse and look around. Excellent. So it means that, yeah, we cannot pass through the fence. We can walk over this fence here. And let's head over this way to see the bridge. There is the rolling sphere. So let's walk up the bridge. Excellent. And now we can turn around and have a look. Awesome. So in just a short time in this particular section, we have managed to put in our first person player. So we've now got something playable. We've got something to do. And yeah, it kind of does start looking like a game now, doesn't it? It's looking like something. And there's obviously a lot more to do. What I would recommend though is, work with whatever you've got. If you want to manipulate some of your player capsule, you can. And you would do that by going to the inspector panel here, and you can change a lot of these settings. I'm not going to change any of them, but feel free to change like the move speed here, the sprint speed, rotation speed, all that can be changed. You can change the jump height and everything. So for example, I will change this one just to kind of show a point. If we were to have this character and jump, then yeah, we've got a cool jump, but you could change this on the fly. Let's change the jump height to 12 and then jump. So you can really see all this happening, and that's in conjunction with gravity. If we set gravity as -1, for example, and jump, you've got kind of like moon physics, and all of this comes back again to the physics as well as the gravity. All of it is in conjunction with each other to really, bring together something. So if we're on like a moon atmosphere, this is perfect now. When we press play again, it will reset to whatever we had previously. So what I would recommend now, before we move on, is you work with all of this. You get the settings right for your player, and then what we'll do is we'll add in a canvas and we'll start working on some UI elements. So in most games you see these days, you have some form of UI. Whether it is classed as a GUI, UI, or HUD, it's all the same thing. It's whatever is overlaid on your screen. That can be text, it can be buttons that you can click, it can be images, it can be many different things. In Unity 6, to get this on your screen, you need to have something called a canvas that overlays your game. And the canvas is the object that holds all the UI information. Now, in order to get this working correctly, what we need to do is go to Game Object, let's go to UI, and then we can select any one of these that involve a UI element. We could just add in a canvas and an event system straight away, but if we select something from the list, we can instantly have that working. So let's select Text Mesh Pro. When we do that, you should get this if you're using it for the very first time. Now this TMP importer is an object that you import some essentials into Unity 6 to allow you to be able to use something called Text Mesh Pro. And Text Mesh Pro is how we can use text on our screen. Text is probably the most common form of UI that you would see in a game. So obviously we have to click Import TMP Essentials. It shouldn't take too long, just a moment to import. And when it has finished, you'll be given the option to import the Text Mesh Pro examples and extras. You can if you want to, it's entirely up to you. For all intents and purposes, we don't need to do that this time, so we can just close this little TMP importer. Next thing we need to do is we need to establish what exactly has happened at this point. You'll see a couple of objects down here. You'll see Canvas, Text, TMP, and Event System. The event system object and the canvas basically go hand in hand. For example, you can't have a canvas without an event system, or you can, it's just that the canvas won't work correctly without the event system. The event system object is not an object that we really need to play around with too much at this point, because we just need to get some UI elements on our screen. Firstly, we need to make sure the canvas is set to our screen perfectly. To do that, we need to double click our canvas. And that will zoom out quite a lot. Basically, the canvas is quite large, but we can arrange that. Firstly, let's go to Game, and you should hopefully see some kind of text on our screen. It doesn't look great, it's a bit out of focus, it's not in the right place. That means that we have to set the canvas. So, in order to do that, make sure we select Canvas, and over here in the Inspector panel, you'll see down here we have something called Canvas Scaler. The canvas scaler is basically used to scale the canvas to any screen size and basically make everything fit in perfectly. For example, if you were to play in a 4K resolution, you want things to appear on the screen in the exact same place as if you were playing on 1080p or 720. To do that, we need to change the UI scale mode right here and set it to scale with screen size. But it's not quite as simple as that. If you notice now, we zoom in here, our text object that says new text has now disappeared outside of this white rectangle. This white rectangle is the canvas and represents what the screen can currently see. So, in order to sort this, we need to set the resolution. Let's set a standard resolution of 1920 by 1080. And we should hopefully see that this text has now appeared inside our screen. If we go to Game, we can see it has indeed appeared just here. You'll notice that it has gotten a little bit smaller as well. That is because of scaling. Next, what we need to do is where we have screen match mode, you'll see it has match width or height. You can select match to match both in the middle. If we were to select this slider, you can see just how much it will try and match towards one axis, either width or height. but we always need it to be perfectly in the middle, so we can set this as 0.5. Now there are plenty of other options within the canvas that you can change, but for basic purposes, for all the basics that you're ever going to need, the canvas is now set up perfectly. So let's have a look at this text object that we inserted. It currently says new text. Let's double click on it. We can zoom in and we can see that we can indeed change several aspects of this text object. Now, one great tool that you can use when dealing with the canvas is called the Rect tool, and that's this little square object here. If we select it, you'll notice that this object now appears with blue dots around the edge. That means we can change the size of the actual object. I always find when dealing with 2D objects that the Rect tool is the best tool to use to manipulate our size. However, if you don't feel comfortable with that, you can change it here in the transform component. You'll notice that this is called a Rect transform component, not just a standard transform component like in other game objects. Anyway, let's set this as 0 on the X and 0 on the Y. There is a Z axis, but don't worry too much about that. We can change it. However, this is just basically scaling the size of the object because it is going back and forth. So although it is a 2D plane, the canvas, we can work in the third dimension, as you can see. However, I wouldn't really recommend it because there are other things that you can do. And when it comes to the game view, you can see it doesn't make too much of a difference anyway. So let's set this back to 0. Back on the scene view, you'll notice this icon here, middle, center. This is the anchoring point. Now, an anchoring point is crucial when it comes to scaling correctly inside the canvas. For example, at the moment it's set dead center. That means that no matter what the screen size, this new text object will always display dead center, whether it is a huge screen or a little screen. However, if we have it set as top left, then it will not always appear in the center. A good way of detecting this is if we take the Game tab, drag it to its own individual object and then increase the size, you'll see that yes, it does indeed stay there. However, we can move this around so it changes position. You can see it's now changed its position to just here and not center. That is because it is trying to keep its logical point of reference in the top left. So whenever you create anything inside the canvas, always be wary of your anchoring point. And if you have UI that appears in wrong places at any point, you'll always have to reference this anchoring point. It's always crucial. So as a good example, something like your reticule in the center of your screen, your cursor, that will always be anchored dead center. Something like HP could always be anchored at the top left or top bottom. And then your objectives can always be anchored in the top right or bottom right. You can also stretch across the screen as well. So if we select the stretch tool right here and go to game view, we can see it's just normal. However, if you change it, you're going to see that it looks like the font size has increased. That's because it is stretching the actual object to be roughly the same size as what it would be on any size screen. This is more apparent when you use other text objects inside the canvas. Like I say, there are plenty of things that you can do further. You can pivot objects as well in the canvas, and you can use all this information to kind of give an effect of perhaps animation inside the canvas, but it's not really necessary. The other things that you can do is you can insert other UI elements. So let's insert a raw image, for example. You can see it's appeared just there. Let's set the anchoring of this to stretch. And let's now play with this and let's have it 0 on the left and 0 on the right. And you can see that no matter what, this line will go all the way across your screen. No matter how wide your screen is, it should adjust. There we go. So no matter how small your screen is, it will adjust. There we go. So as I said, anchoring can actually be quite detrimental to what you're trying to do sometimes because it can be so easy to insert a UI element and forget about the anchoring. So just keep in mind how important it can be because you can basically anchor it to any position, stretch it any direction as well, which is always quite handy. If we go to game object, go to UI again and go to panel. This kind of stretches all the way across the screen, but you'll notice that this is kind of translucent. And this is a good indication of what you can do with the colours as well, because if we take this colour and change it to black, you can see just how much of an impact it'll have on your game. Changing the alpha down here will obviously change it completely, like so. So depending on what kind of effect you want to add to your game using only UI, like for example, we've given our game a green overview now, so like a poisonous kind of environment overview, and we haven't actually used any light at all. If we zoom into our sphere, for example, it's still all just normal. The canvas can be used as an overlay as well, which is very, very handy. So next time what we'll do is we will go back to our text right here that we can't really see now because the raw image and panel is in the way, so let's get rid of those. And what we'll do is we will allow this text to change via C# coding. We'll basically make sure that we can change text or anything via C#. So let's use this text now and let's put it in a place on our screen. Let's create another one and then let's have these being changed inside our code that we wrote earlier. So firstly, I want to set this as a top left anchoring point. And now let's double click the canvas so we can see it a little better. And let's bring this into a place that we can use comfortably in the top left. So let's take this, move it upwards to probably round about there. That looks fine. And I'm going to change this to name 1. Let's hold Control, press D to duplicate. Scroll out a little bit. And let's move it over this side. And let's call this name 2. So we basically have 2 text boxes. Perfect. We can change this inside the C# script we wrote before. So let's find that script. Let's go to our scripts folder and double click start a script and let's open it up. So if you remember, we had the names Jimmy and Fred. Well, let's now add 2 more variables to this. Let's have at the top serialized field in square brackets, again because we want it to appear in the inspector panel, but we don't need it to be public. Let's have this as game object, again remembering capitalization. And we'll have this as name 1 with a semicolon. And if we hit return, it should automatically predict that we want to have name 2 as the second variable. And indeed we do. So how do we make it so as we can change the text based on whatever my name says? Well, to do that, we can either have a line of code that constantly updates, or we can set it here. So we want, whenever number 4 and true is the case, we want my name to be Jimmy. So let's also make the top left say Jimmy. To do that, after we have mygate.setActiveTrue, let's put a new line of code. Let's put name1.getComponent. And the reason we do this is because if we go back to Unity and click on name1, there are components here. And the component we're after is this one, the Text Mesh Pro text, because this box here is where we can change whatever we want the text to say. And naturally we'll get more into this text a little later on, but for now we just want to be able to change this name. So we can say in spiky brackets, because we're referring to a component, TMP, all in capitals, and then little r, little o. This naturally stands for Text Mesh Pro. Dot TMP underscore text, and the capitalization there is vital. So we're now saying that we want to access this component, open close bracket, and then put dot, and then we want to tell it what exactly we want to do with this component, and we want to modify the text, so we can say text. Now we need to say equals, and this is where we can put a couple of different things depending on what we want to do. So this has to be a text value no matter what. So we could theoretically put the integer known as my number here. It wouldn't work because my number is a number That's the problem. When we're dealing with text, it's always looking for text, but that doesn't mean to say that we can't put the number. A way around this, you can simply put a double quote and then put plus and then put my number and then a semicolon. And what this will do is it will assume that it is going to be text, because we're already saying that it's a text value here. It may be empty, it may be blank, but it's still a text value. And then we can add everything subsequently after that. So let's save this script for now, and then let's head back into Unity. Give it a moment just to compile the extra line that we've written, or 2 lines that we've written. And now what we need to do is we need to go to the script holder object, which is this one right here. Because if you remember correctly, this is where we stored the script. Unity is just taking a couple of extra moments there to compile. So let's go to script holder, and you should see these 2 new variables that we can attach. So let's drag and drop name 1 over here and name 2 over here. And now let's press play. So obviously they're both going to say new text just for now. However, if we set everything that needs to be set over here, there we go. We can see that this has now changed. And if we were to change this back to 3, this would remain as 4 because we didn't place anything in the script to be able to change this back to what it should be. So let's delve a little further into this. So what we've done is create 1 line of code to say that this is how you access this particular component and change the text. So let's put this now as my number and then colon space, and then obviously we've got the brackets, and then we can put plus, and then we can put some text again and put my name, and then we can put another quote, and then we can put plus, and then we can put my name. So essentially what we're doing here is we're creating a string value of different things that we can add to this text. And what we'll also do is we'll access name 2 as well. So if this says Fred, then what we can say is after mygate.setActive false, we can use a similar line of code as what we did here. We could say name2.getComponent, because we're accessing that component, the TextMeshPro component .tmp underscore text open close bracket dot text. So remember what we've done here is we've accessed the text component on the second text box, and we can make that equal to let's say Fred is active and then semicolon. So what will happen here is that by default the right text box is going to say Fred is active, and the left text box is going to say, well, new text. So we can always change what that says. Let's actually have this now as another line of code below it, and let's copy this line here up until the equals. Rather than retype it, we can always copy, and then we'll put Jimmy is inactive, and then quote semicolon. And what we'll also do is take this line of code, place it up here, and let's just put some underscores. So all of this really means nothing in effect. It's more a case of we're changing what the text can say on the fly at any given point. So if we go back into Unity, give it a moment just to compile once again. When we start this game, the new text up here in the top left should change, and it should say Jimmy is inactive, and up here it should say Fred is active, or I think we put that, didn't we? So when we change the status over here to 4 and false or whatever it was, both will change. So let's press play, and when we're in we should be able to see that there we go, Jimmy is inactive, Fred is active. So let's change this to a 4. And we can instantly see my number, 4, my name, Jimmy. And we have this one over here as blank. So if we untick, it changes back. And we can keep doing that as many times as we want. Awesome. So the idea of what we've done here is we've created some UI elements, i.e. the text boxes right here. And then within our script, we're writing code that will allow us to change these text boxes and whatever the text would say. You can obviously go a lot further than this. And let's say if we wanted to add in another if statement, we could say that if, and in brackets, my number equals 0, let's say, for example, then we could say that name1.get component in spiky brackets text mesh pro underscore text. If I can actually type it correctly, it would help. textmeshpro.tmp underscore text, open close bracket, dot text equals, and we'll just put blank, semicolon, and then we can copy that line of code as well, place it here, and let's have that as name 2. So what, in effect, what is happening here is we are going to state that this is blank. Now, this is where things may get a little bit, not difficult, not haywire. However, you'll notice that there are multiple ways and multiple things that can happen, and hopefully we should see something happen here. But if not, I'll explain. So if we press play and wait for Unity, as always. So it says Jimmy is inactive, Fred is active. So let's go to the script holder and let's change this to 0. Both will disappear. Now, if you think about it logically, what is actually happening here? Because this should actually be the case. Because remember, we have an if statement here that says if it's 4 and true, then do this. If it's anything else, then it should say this. Now, the reason it doesn't is because this if statement supersedes this one, because these lines of code are being performed after this one. If we were to change this line of code around, then it would be blank here, and Fred is active and Jimmy is inactive here. And this is a prime example of knowing if something in your script is colliding with itself without you even knowing. Because at this moment, this else statement and this if statement are both true. And something like this could cause issues in the long run, but I wouldn't worry about it too much. At this point, it doesn't matter too much. The idea of what we wanted to do was change the text. Fonts and text go hand in hand when it comes to Unity development. And so far, the actual text we only have is the default one for all of these. So how do we bring in some fonts and use them easily inside Unity? Well, firstly, let's create a folder specifically for our fonts. So here, assets, right click, folder, new folder, let's call it fonts. And I'm going to drag and drop 2 fonts into this folder. Unfortunately, I cannot link you to them because I do not have permission to distribute these fonts because I do not own them and don't have a license or anything like that. So you can use any font you want. You can go through your fonts folder, or you can go to a font website, find one you like, download it, import it into Unity. Now, unfortunately, it is not as simple as being able to go to your text box and dragging and dropping your font here. You actually need to create a font asset. And to do that, you can go to Window, and down here you'll see Text Mesh Pro, and you've got Font Asset Creator. If we select this, you'll be presented with the little window, and all you need to do is select the font you want to start with. So in this case, source font. If we select it, we can find one that we like. So let's start with this one. And let's click the little red X. For the most part, you won't need to change any of these other settings. These are for more customized fonts. For now, we just want to be able to convert our font into an actual usable asset, and that's fine. So we can just click on Generate Font Atlas. It will take maybe a second, 2 seconds, but it will generate an actual asset. Now what you need to do is save that asset. So save, and then save it as whatever it is with SDF. Save that, and you'll notice the icon for it has now changed into a giant F, which is very similar to this font asset section over here that has a giant F. That now naturally means that we can drag and drop this font asset over here. So drag and drop onto there. And if we go to game view, you can see it has indeed changed the font. Now for every font you have to go through that same process. You can't just drag and drop either way. So it's real quick though. Again, if we just rush through it, we can see Text Mesh Pro, Creator. Let's select our font, Corbel, that one, create, and then save as, and then save. Perfect. It's as quick as that. I don't find it much of a hassle, to be honest. I think it's fairly decent, fairly straightforward, and very simple to create font assets. So let's put that second font on the second text box. And although we selected it from the little button there, you can still drag and drop, and there you go. So we have two separate fonts. Naturally, you can revert to the original font if you wanted to. So what else can we do with these fonts to make them look cooler and better? Well, let's start with this one, name 1. Let's change the colour of this one. Let's have this one as a lime kind of green colour. So you can change colours quite easily. Let's have it bold and let's have it underlined. Font size, I think, is too small, so let's increase the size. But when we do increase the size, we'll need to make some modifications to the object itself. So let's have the font size as 52. Obviously, it has grown bigger. It looks okay. Maybe it's still too small. Let's try 100. Naturally, it's still a small object. So what we'll do is we'll take our rect tool and let's expand the text box to about there. Make sure it looks okay. Cool, I'm happy with that. And I want to make sure that it is in the correct position, align-wise. So let's have it, yep, definitely aligned on the left. Let's have it center of our text box. That's fine. Zoom out. And while we're at it, let's change how we can customize this text box, which is name 2. I want this to be a red kind of color. Let's also have it as 100 and let's change it here. And as we do this, you should hopefully see that we have a blue line which now underlines our name 1 box. And what that means is that this text box we are aligning and it is snapping to be the exact same size as our other one. So we could drag it even further to here and you'll see that it does snap towards here. That means that our UI is now identically aligned, and that's good. So if you want to manipulate and adjust text boxes, you can do just that, and it looks like this. But I want to put this aligned to the right, and I want it in the center. So let's change the alignment, and let's change it there. So a lot of what we're doing here, as you may have already guessed, is very similar to if perhaps you were creating something in a Word document. You can change what the font actually looks like. It's worth noting that this series is geared towards Unity 6, as you already know. However, if you're using an older version of Unity without Text Mesh Pro, then this is not possible. The old way of doing text in Unity doesn't have as many options as this does. Let's set this as bold and let's set it as italic. I think that's kind of cool. We can also select different things here. If we want text wrapping, you can wrap it if you want to, but we'll explore this in just a moment when we press play again anyway. So I'll be able to show you. Overflow, you can do what you want with. It's entirely up to you. Here you can play around a little bit more with the shader. We won't get into shaders at the moment, but this is just basically a way of being able to customize your text further. And I would recommend playing around with some of these settings if you want. For now, let's press play and see what happens, what our text looks like. So Jimmy is inactive, Fred is active. So let's change the script here and let's turn that off. And Jimmy is inactive. Oh, actually, no, we want to change it, don't we, to 4. There we go. So my number 4, my name, Jimmy. So that all comes down perfectly fine. However, we now need to explore the wrapping of it all. So if we go back to our scene, select the text one, and let's put this text far too big. Let's put this as 170. And let's press play once again. And we'll be able to see what happens with the text itself. We have, I think, already seen it when we had the simpler looking text. But let's go on script holder once again, and let's change this to 4. And you can see just how it's wrapping like that. It goes around and it changes exactly where it is. So we could always turn that off and it goes back to normal. Now, on name 1, if you scroll down and go to text wrapping mode, you can change it from normal to no wrap. And again, it comes down to perhaps if you've used Excel before and you know what wrapping text in a cell looks like, you know, it comes down to that. So if we set this to 4, you can see that even though our actual object itself ends here, because we're not wrapping anything around, it will extend beyond that. So it's always worth testing things out to make sure that they work as intended. Because sometimes you don't want UI to intersect like they have right here. So either change the size of your font to make sure it is correct, or use the correct wrapping mode. Maybe use a different font as well, because if we, for example, use the Corbel font here on the first text box, it would look a little bit different again. And there are things that you can kind of do with it to create other effects to it. It just depends what you want to do. For example, this name 1, if I was to hold Control, press D, it will create a duplicate of it. I could then zoom in, and on name 1, the original one, I could actually change that to black. And then perhaps move this just ever so slightly like that. And you can see that it now, if I zoom in on the game view, it does have that black outline at the back. It's not the best way of doing it, but if your text is never going to change, it just wants something like that, then that is a cool, quick and easy way of creating perhaps a shadow effect. And going a little bit further, if you wanted to change the colouring of it, you could change the alpha perhaps, so it kind of fades like that. It kind of gives that flashing effect. But again, all that comes down to how you want your text to look on screen, because there's so much you can do with it. And it's not just text elements that can have that kind of impact. I'm just going to delete that extra one there because I don't want that. Let's undo it. There we go. So now we're left with our 2 text on screen. So last time I actually forgot to import that wooden house that I said I was going to. So let's actually do that first real quick. Let's go to our objects folder, drag and drop. And I will leave a link to this in the pinned comment if you want to head down there, download it, and you can. The idea of this was to just show that you can quickly and easily add materials and everything to a house. So we'll do that and then we'll go into the UI buttons. So if we go to where our bridge is, zoom in a little bit, let's go to our wood house, drag and drop. It's a little bit big, so let's decrease 0.25, 0.25, 0.25. And as you can see, it is just completely grey, mainly because of the material. It is just the standard material there. But what we can do is right click on the farmhouse object, prefab, and let's completely unpack. And next thing, let's go to the materials and let's drag and drop this object onto here. So this is the texture that goes on just fine. It's created another material folder, but we can play around with this and do whatever we want to it. You know, we've done this kind of thing before. I'd recommend just playing around with it and making sure you're happy. Anyway, did I say you can download that for free from the pinned comment? I think I did. Anyway, let's talk about UI buttons. So what are UI buttons useful for? Well, when it comes to mobile gaming and development, buttons are very, very useful because the way Unity 6 incorporates buttons is they're already preset for a touchscreen, which means you don't need to do any extra programming to get a button to work on a mobile device. In this case, what we want to do is let's take a look at a button and let's put some code on the button to do something. The idea of what I want to do is open the gate whenever we press the button. So let's go to game object, let's go to UI, and let's go to button, if I can find it. There it is. And you can see it is in the center of our screen on the game view. It's very small. Let's put it in the bottom left. So let's use our rect tool and let's expand it so it's a little bit bigger. And then let's drag it down to the bottom left, have a look at game view, and that looks fine. Let's set the anchoring position to bottom left, and let's take a look at the button itself. It has this text. Well, let's actually name this something. Let's put open gate. And like with the text objects that we've had previously, you can change the font if you want to, because we already have the font asset. We can change the size, scale, color of it all. So let's have it as 50 and let's keep it as that color. The button itself has a couple of different options there too. So its normal color is currently white. We can change this if we want. Let's have this as a blue color. And if we go to game view, you should be able to see it just fine. Highlighted color means whenever our mouse is hovering over it, what color do we want it to be? What about a kind of off blue color? There we go. Maybe that one. Press color, let's have it as a deep blue. So whenever we press it, we want it to turn deeply blue. Selected color doesn't really matter too much. Let's have it maybe as a purple. I just want to kind of illustrate what you can do and how you can customize buttons. Disabled color is whenever it isn't in use, so it's kind of faded. That's why the alpha on it is currently set as 128. If we press play, we should be able to see these button actions and colors working. So its normal color is as it is, and if we hover over it, we should be able to see. Ooh, if I have my mouse, it goes different. If we click it, it doesn't want to click. Let's actually try that again, because we don't want it to. There we go. Right, so once again, let's press play. And right, it's not working as intended. So let's customize this a little bit more. Let's take the main camera from the player and let's place it just above the player. And then we can turn the player capsule off and then press play. And what this will do is it will give us the ability to actually interact with the canvas a bit better than what we would have done. There we go. Because at the moment, because we have a player capsule in the scene, that is overriding what our mouse is doing. In this case, it wasn't allowing us to open the gate. So if we have that there now, you can see when we select it, it turns that deep blue. And it is selected. That's why it's now that kind of pinky purpley colour. So we know our button is working. Next thing we want to do is we want to make this button actually work. Now to do that, I need to reset a couple of things in our scene. So let's get to work on that. Let's go to our gate, zoom in, and let's turn the gate back on. Now, if you recall, the gate itself already has an animation set to it. So if we were to press play, for example, it would play that animation. Now, what we're going to do here, oh, actually, now we think about it, this script holder will need to modify that. But what we'll do in the meantime is we now need to make it so as the gate doesn't automatically play an animation. We want the button to be able to control that. So what we can do is if we scroll down to Animator, you'll see Controller Gate. Double click this and it will open up the Animator tab. You should see Gate Swing highlighted in orange. And what we need to do is prevent this from running. So to do that, anywhere in the grid, right click, Create State and click on Empty. And then on this new state, right click again and set as Layer Default. What this means is no animation will play, but we'll be able to call this animation in a script. So let's head back to our scene view. Let's go to the script holder and let's go on to Start a Script. So at the moment we have all of these set as you would expect. And all of this is in control, saying that the gate is active, the gate is inactive. So what we want to do is let's use annotations. Do you remember when we first started coding, we had those green lines? Well, you can actually make normal lines of code green. So if we put a double slash there and there, that will prevent those two lines of code from running. So now if we save, head back into Unity, give it a moment just to compile. Because our gate is now turned on, we should be able to see that gate, but the animation will not play. Let's make sure that is the case. And give it a moment, and there we go. Perfect. So, what's the next course of action? Well, what we need to do is create a method to allow ourselves to open the gate. So heading back to the script, remember we have void start, void update. Well, you can actually call a method anything you want. So follow this line down from void update, hit return a few times, and let's type public void open gate, open close bracket and open curly bracket, and hit return. Now, why do we use the word public? Well, in simple terms, to cut a very long story short, if a method is not public, a button will not be able to function. So for us to attach a method to a button, it has to be public. So what do we want to happen whenever we press open gate? Well, it's very, very simple, isn't it? All we want to do is make that animation of the gate play. So in order to do that, we can use something similar to what we did when we got Fred is active and Jimmy is inactive. We need to access the component. So firstly, we need to reference my gate. So we can say my gate dot get component, and in spiky brackets, the name of the component we need to access. In this case, it's animator, because that's where our animations are stored. Animator, open close bracket, dot play, and it's a capital P, and in brackets and quotes, the name of the animation that is the gate opening. So if we go back to Unity, go to animations, and it is gate swing. But what I'm going to do is I'm going to copy the name of the actual animation rather than retype it, just in case, because if you spell it wrong, it won't work. And then place it inside there, and then semicolon to finish, and save. So the beauty of all of this is that this method will not run unless we attach it to something. So if we head back into Unity, give it a moment to compile, what we essentially have to do is modify the button to know that whenever it's pressed, it has to run that particular method. So we can go to our button right here, and if we scroll down in the inspector panel, you'll see on click list is empty. So this is where we can input something when it's clicked. So we can press plus, and you'll see here runtime only. We now need to select an object in here. So drag and drop our script holder onto here. What this means is that whenever we click it, it knows it's got to access this object. So when we click no function, we can then click on start a script. And in start a script, that's where you'll see open gate. So if we click it, that now means that the button is set up for us to run open gate whenever we press it. So if we press play now, we should be able to press this button and this gate will open. Perfect. And if we do it again, it's not going to work. The reason it's not going to work is because the animation is only set to run once. We essentially need to reset the animation for it to happen again. Just to give a bit more context to it, if we go back into Unity, you could reset the animation here, but it's up to you whether you want to. It doesn't really matter if you do or not. The idea is we just wanted to get the button working. And there are different things that you can do. So it's also amazing how quick you can actually set up buttons and get them functioning. So, for example, let's quickly set up another piece of code. So let's hold Control, press D to duplicate that button. Bring it over here. Let's change the normal color to green. Let's change everything to a kind of green color, like so. Selected color I'll keep as purple just because I can. Let's change the text to say hide other button. And I'm pretty sure you've already guessed what's going to happen here. So let's now make this button hide this button. So let's go back into our script and let's declare the first button as a variable. So we need to serialize field in square brackets, game object, and we'll put first button with a semicolon. So naturally that means that we now need to create a new method. So we can say public void hide button, open close bracket, open curly bracket, and we can say first button dot set active, and in brackets false, semicolon, and save. And if you do have any problems with these scripts, as always, they are in the pinned comment in the description. You can go there, click on the link, and get the script for free. So now Last thing to do is just make sure this button does what it's supposed to. Now, because we had a duplicate of this button, we duplicated it from our first button, when we go down to on click, there is already something here. This is where you need to be very careful about how you set up your button, because logically you think it will work. But if we were to press this button, it would just open the gate. So we need to make sure that we change the method that is run. And we can do that here by selecting Start a Script, and then we'll click on Hide Button. And finally, what we need to do is on Script Holder, we need to declare first button as that one. So whenever you add a variable into any script, always make sure that you do declare it in the correct manner. So if we press play now, we should still be able to click our Open Gate button and it will work. But then as soon as we click our green button over here, it will hide it. So Open Gate, but let's hide that other button. Done. And if we press it again, it doesn't really matter, simply because it's already hidden. So there's so much you can do with buttons. A good example would be, as I said, for mobile devices, you can have a button that maybe moves a character forward or left or right or changes to a different level or something like that. Buttons are incredibly versatile and they're one of the greatest things to play around with, at least in my opinion, when it comes to UI development. So fade screens are crucial and they're actually very, very easy to implement, but when it comes to where they place inside the canvas is actually very important too. So for starters, what I want to do is I want to add in an object that will fade from black into our game. And for the time being, I'm actually going to re-enable our player capsule and add the main camera back to the player camera root, just so as our game is indeed playable. It's up to you whether you want to turn the buttons off at this point. But to do all of this, what we need to do is go to Game Object, go to UI, and let's go to Raw Image. It may seem a bit strange doing this at this point, an image is a fade screen, but it works, and it works well. We'll call this Fade In. At the moment, it's just a little white square, but we will set the anchoring to stretch across the whole screen. So then we'll set the left 0, top 0, right 0, bottom 0. And what that will do is cover the entire screen in white. Let's now change the colour to black. Like I said, I want this to be a case of a completely black screen, i.e. we've just moved to our level and we want to fade in. In order to do that, it's all via animation. So, like we've dealt with animation before, if we go to our animations folder, make sure we are selected on Fade In, go to Animation right here, and let's click on Create. Let's set this as Fade In, and then press the Record button. As we've done before, we need to set that first keyframe, and remember that first keyframe is the point of starting, so i.e. the state it's in right now. As we'll only be dealing with the colour, we just need to modify this colour here. And it's all going to be done via alpha. Alpha, if you're unaware, is how translucent, transparent and opaque something is. So if it is 255, it is completely opaque. If it is 0, it is completely transparent. Anywhere in between would be a translucency. So we need to set this number as 255. If it's already set as 255, you just need to retype over 255. And what that will do is set the first keyframe, as we can see. Next thing to do is establish how quickly you want to fade into your game. If you want a quick fade screen, you could go to frame 30, which would be half a second. If you want a nice, slow, dramatic fade in, you could go to frame 180, which is 3 seconds. So let's try frame 180. And what we need to do is set the alpha down here to 0. We can then close that and then press the record button. And if we go to project, let's go to the fade in object right there and untick loop time. We don't want it to keep fading in and fading in and fading in, so we just need to turn the loop off. Now, in simplicity terms, if we press play now, that's it, we've got our fade in. But there's much more to it than what we see. There we go, so we're fading in there and we can wander around our game. Awesome. Cool. However, if you place the fade in, let's say somewhere here, it's going to look a little bit strange because it means that our buttons are they're in front of it. They're not being faded in. So in terms of placement inside the hierarchy, the fade in screens are more than likely always going to be at the very bottom. So the ordering of everything inside the canvas determines what is displayed first. For example, if we were to put the fade in at the very top, we'd still see everything that is on the canvas, and we don't want that to happen. We want everything to be hidden behind the actual fade in. Now, there are some games where they have the subtitles still on top even though it fades out, and yes, theoretically you can do that. So if you were to go to Game Object, go to UI, go to Text Mesh Pro, let's center it in the bottom quickly, let's call it subtitles, and let's zero the X position, just quickly increase font size, just to kind of give an illustration of what things would look like. That'll do. Okay, there, and let's put, these are some subtitles for the game. That should do the trick. And as you can see, they are on top of the fade in. And like I say, some games do actually have that. So if you wanted it to be like that, then perfect. But if not, you would have to make sure that everything else covers up. So basically, fade in is the bottom tier inside the hierarchy on the canvas. So that means it fades in perfectly. Excellent. So when it comes to changing your mind, for example, what you would need to do is if you go to fade in, go to animation, press record again, and let's say you want to fade in super quick instead. Let's take our keyframes and just bring them to here. Press the record button again, and let's press play. And it should fade in much quicker. Excellent. So what about fading out? Well, every game has some kind of fade out, doesn't it? So it's the inverse of this. You can essentially do the same thing again. So what I'll do is turn off fade in, and then let's go to Game Object, let's go to UI, and then let's go to Raw Image. Same thing again, let's call this fade out. And we want to stretch everything, so it's the same kind of process, but the animation is inverted. So you could say fade out. We could fade out to a completely white screen if you wanted, so let's give that a go. However, the initial color has to be 0 right there on the alpha. Next thing, let's go to animations, fade out, animation, create. It really is as quick as this. Once you get in the rhythm routine, you can see just how quickly some things can be developed. And you've probably already noticed this already throughout the course of me teaching you Unity 6. You're getting quicker and quicker at doing things. So we know we press the record button. We've got to set the alpha back at 0. So let's set it as 1, then 0. There's our first keyframe. And let's have it fade out over 4 seconds. So let's do 240, just for something a little bit different. The alpha is then set to 255. And let's go to this record button, press stop, project. Let's go to fade out and press the loop button and then press play. And we should be able to see slowly our screen fade to white. Awesome. Obviously, if we were to loop it, and let me quickly show you what that would look like, because that's not what we want to see at this point. But if we set it like that, it would fade to white and then it would repeat itself again, which is why we always undo loop time. Now, if we go to the fade out screen and go to animator, you can see fade out is right there. You could essentially change things here as well in the speed. You've got an opportunity to change the value. If you set this to -1 and press play, you will see something. Notice anything? We're doing the exact same animation but backwards. And it raises the question, do you ultimately need 2 objects? Do you really need the fade in if you've got a fade out? Do you really need a fade out if you've got fade in? The answer is it's entirely up to you. In terms of resources and everything, having 2 objects that do ultimately the same thing isn't going to make much of a difference. Coding wise is how you would change how your fade in and fade outs work. So I'm going to set my fade out back to 1. And the idea is that if we had the fade in set on and the fade out set off, we could change the fade in to be -1 and then press play, and you'd have the same effect as fading out. So one animation is played forwards and backwards. You could theoretically do that, and that desired effect is achieved through coding if you wanted to. However, the easiest way of doing it is just having two objects and referring to one or the other. It genuinely is the easier way of doing it, but I guess everyone's different. Depending where you are in your game as well, it's a case of, is it ready to be faded in? Is it ready to be faded out? Can you do it at certain points? Well, yes, you actually can, and that's what we're going to do in the next segment. So what I'm going to do is I'm going to zoom in on our gate just over here. And the general idea of what we're going to create this time is we're going to create a sequence of events using a coroutine. And a coroutine is a way of controlling things time-based in your game. And it's all done via C# coding. So the first thing we want to do is to fade in our screen. And then we need to turn the fade in screen off. Next thing we're going to do is we're going to make our gate open a couple of seconds later, and then we'll fade out. And that will be essentially a sequence of events. So how do we do this? Well, let's start by going to the script that we've already written. We can go to scripts and start script. And yes, we already have all of this in here, but that's completely fine. We'll keep all this as it is. A coroutine can be written inside this script, and it doesn't matter whether you want to create a new script or whether you want to keep expanding this script. And as I always say with these scripts, go to the pinned comment and you can download the script that we will eventually write in this part of the tutorial. So first and foremost, how do we create a coroutine? Well, let's go below our hide button method, and we need to type enumerator, and then we can call it anything we want. So let's call this my sequence, open close bracket, open curly bracket, and hit return. Whenever we declare an enumerator, this is known as a coroutine. You'll notice that the name is underlined in red, and this looks like there's an error. If we were to save this script now and try running our game with it, it would error, it wouldn't work, because this is indeed an error. The reason it's an error is because it's expecting to, in simple terms, wait for a given amount of time within its own coroutine. We're not going to do that just yet. We're actually going to refer to a couple of different things as variables. What I will do is I will scroll to the top, go to where our variables are, and I want to go down just a couple of lines. So the variables we're going to use in this, we need to add in the fade in screen and the fade out screen. We already have the gate here, right there, so we don't need to declare it again. So we need to type in square brackets, serialize field, and it's going to be a game object, and we'll call it fade in with a semicolon. Next, we need to do the same thing, except it's fade out. So let's go back to our coroutine, and what we'll do first and foremost is we will wait. Now, our fade in screen lasts, I think at the moment it's like half a second. So what we'll do is we will wait for half a second as the first thing in our coroutine, and then after that we'll turn off the fade in object. So we need to put yield return new wait for seconds, and in brackets 0.5 f close bracket semicolon. And let me just correct my own spelling there. So why do we put an f here? Well, anytime that you use a decimal number, you always put an f after it. It's known as a float. So a decimal number in C# coding, whenever you're in Unity or whatever, is a float. Just keep an eye on that. When you're putting a whole number, you can still put the f, but it doesn't really matter if you do or don't. It still reads it as a whole number. And you'll notice at this point, the underlying has disappeared from my sequence. That's exactly what we need. So what would we want to happen next in this event? We want fade in dot set active false, because we want the fade in screen to disappear. It doesn't need to be on anymore. Next thing, let's actually play the animation for our gate. So we can actually use this line of code right here. So we can take that, place it here, and then after, let's say, how many seconds should we say? Should we say 4 seconds? We'll do something else. So we can say yield, return, new, wait 4 seconds, and in brackets, we'll just do 4 with a semicolon. So after 4 seconds, what else can happen in our coroutine? Well, why don't we change one of our text things to say something, or should we turn something on? Shall we, tell you what, should we turn our first button off? So let's take this here and let's place it below there. And then we'll wait for some more seconds. So let's say yield, return, new, wait 4 seconds. Let's wait for 5 seconds with a semicolon. And for now, let's head back into Unity and see what we could actually do. What can we do exactly? Well, I'll tell you what we can do. See these fences where they fall, right? So they fall round about there. So what we'll do is here, let's put a big sphere. So let's go to Game Object, let's go to 3D Object, and let's go to Sphere. And let's place it roughly where this fence actually is. So round about there, let's place it there. And let's increase the size. So let's have this scale as 5 by 5 by 2 maybe. We'll see how that pans out. In fact, no, we'll have it 5 by 5 by 5. Round about there. I think that's great. Next, let's turn off the mesh renderer. And let's call this hidden sphere. So now let's go back to our code and let's declare that as a variable. So we need to serialize field in brackets, square brackets that is, game object, and we'll call it hidden sphere with a semicolon. So then after we've made that button disappear, so let's wait for 2 seconds instead. We can say hidden sphere dot set active, and in brackets true with a semicolon. And then we'll wait for another 2 seconds, but what we'll do actually is copy this line of code, and then we'll say finally fade out dot set active, and in brackets true semicolon. So this is going to be our sequence of events, and this is the coroutine. So when the game starts, we're going to wait for half a second, and then we'll turn the fade in off. And at the same time, we will make our gate open. After 4 more seconds, we'll turn our button off. After 2 more seconds, we'll make the sphere appear. And then after 2 more seconds, we'll fade out. So the last thing we need to do is in void start, we need to tell it to start the coroutine straight away. So we can say start coroutine, and in brackets, the name of the coroutine you've written. So my sequence. Open close bracket once again, semicolon, and save. And as I said, you can download this if you go to pinned comment and click link. So let's head back into Unity. And what I'll do is the fence right there, when Unity's had a bit of a think. Taking a moment just to compile there. So I'm going to take this fence and just bring it back up to here. And next thing we need to do is go to script holder. Because we've modified the script, we've got some more variables we need to add. So let's add them in here. So fade in and fade out, and hidden sphere is right there. So just to quickly recap before we try this out, we've added 3 variables and we've now got this coroutine happening. So let's press play and hopefully let's see this sequence of events actually occur. So when it decides it's going to, there we go. So that's opened. I forgot to turn hidden sphere off. One thing there we go. So let's turn the hidden sphere off try that again. So that's okay. Yep. So the button should disappear in a couple of seconds, and it does. And now the hidden sphere should appear. It did. It turned on, and then fade out happens. So one thing I did expect to happen that it didn't, and I think it's because I need to add a rigid body, but these fences should have shot up in the air again, just as like something that would happen that we could visibly see. So let's add a rigid body to the hidden sphere. And let's press play once again and see this sequence of events take place. Okay, so there we go. Fade out, button should disappear. And the sphere, there we go. So the hidden sphere did appear, and we did see those fences jolt a little bit. So I think I press play again then. So what we'll quickly do is, I wonder if we can change the size of our sphere just so we can make it have a bit more of an impact. So maybe something like that. Okay, last time, let's try this sequence and then we'll talk about what we'll do next time. So as you can see, yeah, all the sequence of events seems to work just fine. Everything we told it to do is indeed happening. There we go. The hidden sphere has just done that to our fences. And there we go. Fade out. So the fade out is currently set as looping, I think. So let's untick that. Music is great. I love music. If you know me, you'll know that I adore listening to almost any type of music. I do have personal favourites. But when it comes to video game music, when you're developing, there is so much you can do. What I'm going to do is I'm going to create a new folder specifically for audio. So in our assets folder, create a new folder. Let's call it audio. And inside that, I'm going to create another folder just called music. So anything music related or background music you could place in here. And I'm going to drag and drop one of these files into Unity. And as always, link is in the pinned comment and the description. If you go into there, you can download it for free. So what we need to do is we need to find a way of getting this audio file into the game to have it playing whenever we are in the game. To do that, we can either attach it to something like the script holder, or we can attach it to a brand new object, and it's up to you how you want to do it. For now, I'm going to go to Game Object, create empty, and we'll just call this BGM. That's generally short for background music. Drag and drop this audio file onto BGM, and you'll see a couple of different options in the audio source component. We're going to play around with some of these to see what kind of effects that we can come up with. So to start with, I am going to press play. And this will automatically play the music. Mainly because we have play on awake ticked just over here. We also need to tick loop when we're outside of this. But before we do that, I want to lower the volume, because that's far too high. But you can see just how you can change it. But what about if we change the pitch? You get a different type of music. So why don't we actually try that before we begin the game? So what if we tick loop? And what if we bring the volume down just a little bit? Well, quite a lot actually. And let's have the pitch as low. Let's have it 0.79 and let's see what that sounds like. It should be quite deep. Yes, I'm quite happy with that. Kind of sounds like something you'd expect to hear from, well, I'd say the Elder Scrolls, but more specifically Skyrim. So I'm going to increase the volume a little more. And if we untick play on awake and press play, it ultimately means that it will not play. So when we tick the box to play on awake, it does indeed mean that as soon as the device becomes active, it will actually play the music. And in this case, because although the object is set as active, because play on awake is not ticked, it will not do anything. What we would need to do is in the game view, tick play on awake, untick it up here, and then retick it, and it would start. There are some other options down here. So you've got spatial blend, stereo pan. If you were to wear headphones, for example, you could actually use these options a little more to your advantage and use them in different kind of ways. Another thing I want to kind of illustrate here is if you were to take the BGM object, hold Control, press D to duplicate it, we've now got two. It ultimately means that two audio files are going to play at the same time. So if you were to change the pitch of one, for example, to be much higher, this is going to sound probably quite awful. Now I think about it, we haven't got play on awake ticked on either of them, so it wouldn't. So make sure we do tick play on awake and then press play and see what that sounds like. I mean, actually, that doesn't sound too bad. It sounds scarily creepy, I guess. That actually worked out better than I thought it would. But I'm going to get rid of that second background music. But either way, what I would recommend is finding the right background music that suits your game and play around with some of these settings to kind of get that impact you want. You can even change some 3D sound settings. For example, the Doppler level, if you wanted to. It's just a naming convention. Spatial blend. But generally, playing around with the volume and pitch, play on awake and loop is probably sufficient enough in most cases. Let's move on to sound effects now. So I am going to disable the background music object and I'm going to add in a new game object and call this one Ding. You'll understand why in a moment. In the audio folder, right click, create a new folder, and let's call this FX. FX is just short for sound effects. Drag and drop this ding into the folder, and when you download the assets in the pinned comments, this will be included. Just make sure you always unzip before you try including any imports into Unity. Same thing again, if we go to ding, drag and drop onto there. Let's tick loop on this one. Let's keep volume as 1, let's keep pitch as 1, and let's press play. And this will keep dinging, ding, ding, ding. There we go, so there's a sound effect. Cool. So what happens though if we want to play a sound effect on command? Well, what we can do is untick loop and untick play on awake. That second button that we have on our screen, the green one over here, let's change what that actually does. We have our sound effect in place, so we don't need to do too much more in that case. Just 2 lines of code should probably do the trick. So let's head back to our script and let's go and add in another variable at the top. So we can say serialize field, and we'll call this one audio source, and we'll call it just ding. But already, you know, we've done a lot of coding throughout all of this, and you can see just how many different types of variables there can actually be. So the hide button thing, remember that says first button.setActive. Let's put / here to annotate that out. And let's replace it with a line of code to play a ding whenever we press the button. So to do that, we say ding dot play, open close bracket, semicolon, and save. And it's just as simple as that, literally 2 lines of code, and we can play a sound effect on command. So let's go back into Unity and make sure that works. Give it a second just to compile. And as you already know, because we've added a new variable, we need to drag and drop that onto script holder. So drag and drop ding over here. So now when we press play, our sequence of events is still going to play. That's fine. That's, you know, something that we can deal with. It's fine. But let's press hide the button. Of course, I forgot. We need to detach the main camera because it still thinks we're trying to play the game. So let's disable all that for now. Let's press play and let's press the ding button. There we go. Perfect. Let me change the text on that as well, just so we don't get confused at any point. Make a ding sound. So we've just basically changed what that button does, and we've now got a cool sound effect in there that we can play on command. Awesome. So like I said, sound effects can really be changed, and something like this ding sound, if you wanted it to be different, like if you're in a world with collectibles and you want this ding sound to be for one object, but then you've got another object which is even cooler, you could have a higher pitched ding sound, duplicate it, and have the same thing. So the same sound file can be played in two different ways. There we go. And in the same vein, you could change the pitch lower and play it once again. So you'd have a lower pitch. Cool. So the amount of opportunities you have when using sound effects in Unity just by changing something like the pitch is just so beneficial in so many different ways, because then you don't need to have multiple different sound files in the game. You can just have one and then you change it on the fly in the engine itself. So I did mention collectibles a couple of minutes ago, and that's what we're going to cover next. We're going to have something in this little game that we can go around and collect and play a sound effect as well. So because this segment is going to be all about actually playing the game, what I want to do is turn off the ability to actually run our coroutine that we had earlier. And all I'm going to do is just turn off the starter script. And that'll give us the ability to wander around and do what we need to. So in doing so, we need to turn on our player and we need to add the camera back onto the camera root. Next thing I want to do is I want to import another sound effect, much like we did last time, but this one is specifically for a collectible gem. So I'm going to drag and drop this collect sound into my effects folder. And then I'm going to go to my objects and I'm going to import this gem. And you can get these in the pinned comment or the description. Click the link and you can download them for free. Just remember to unzip before you try importing into Unity. Now what we'll do is we will create an object that can house the gem itself. So if we go to Game Object, let's go to 3D Object and we'll stick with Cube, because Cube is the most versatile and fundamental object of game development. Let's select the middle of the scene for it, so 0, 0, 0 on the transform. Let's bring it out the ground and let's bring it over here. Let's rename this to Gem. And let's go into the Gem folder in Objects, go into Prefabs, and you can see you have a couple of different gem options. They all are pink at the moment, but we can easily change that. So we'll do a couple of things that we've learned previously, and you'll see how all of these things can come together to create a different desired effect. So drag and drop this gem onto the gem object, which is the cube itself. And if we double click, we can see it is fairly small, so we do need to increase its size. So let's change this to 50 by 50 by 50. Let's move it downwards so as it kind of mingles into the cube a bit. It might be a bit too big actually. Let's have it as 40 by 40. That looks great. So if we go a little bit further and go onto the mesh of this particular thing, you'll notice Mesh Collider. We want to remove the Mesh Collider because we don't really need it. It's not important to what we're trying to do here. The gem itself, which is the cube, let's untick Mesh Renderer. And then let's press play and see how this actually looks in our game. It should just be a pink gem-shaped blob. And it is. So it looks like it's intersecting the floor a little bit. So let's bring it upwards and make sure it's out the ground. And now let's actually make it look useful. Let's make it look like a decent color. So remember when we created materials? Well, why don't we just create a new material by right-clicking, and we can click material here, and we'll just call it red, because I'm going to have this as red. Set the color to red, and then drag and drop onto there. You can change the metallicness if you wanted to, make it look cool. I guess it's entirely up to you what you want it to look like. But for all intents and purposes, there's our collectible gem. Next thing we need to do is we need to write a script which will allow us to physically collect that gem. And this requires a couple of different things with a couple of different triggers and physics again to actually get this working. What we will do is the ding sound that we have here, I'm actually going to replace the audio with the collect sound. So over here, let's replace ding, let's select the button, and let's have collect. Close that, let's change the pitch back to 1, and let's write that script that will allow us to collect it. So let's go to scripts, right click, create a new script, and we'll call this gem collect. And let's open that up in Visual Studio. Now, fundamentally, there's only one thing that we really need to have on here, and that is basically the ability to play a sound effect whenever we collect this gem. So that means that the first thing we need to do is serialize field, as we already know, and have audio source, and we'll call it ding, same as before. So that means that instead of having a start method or an update method, we need an onTriggerEnter method. That means that whenever something enters this area, which would be the player, we get to play the ding sound. So delete all of that, so we only have this variable declaration inside the class, and then we can say void onTriggerEnter, open close bracket and open curly bracket, and if the word private does appear by automatically, you can just delete it. It doesn't need to be private, that's fine. Next thing we need to say is ding dot play, because we want to be able to play that collectible. Next thing we need to say, at least for now, that this game object needs to be destroyed. The reason we want to destroy it is because we don't want the ding sound to be played over and over and over. You could also set it as inactive, but I guess it doesn't really matter. For now, we're just going to put destroy, and in brackets, game object, and that's a lowercase g. Remember earlier when I spoke about uppercase and lowercase on game object being two different things? Well, this is a prime example. So now let's save this script, and let's head back into Unity. We need to essentially get this script onto the gem, attach the ding sound to the variable, and then set up a trigger. And what I'm going to do is I'm going to do a couple of different things so we can experiment and see what theoretically happens if we have different settings set up and try to collect the gem. So let's drag and drop gem collect onto our gem. Let's tick is trigger down here. And then further down, we just need to add the ding sound right here. So we can drag and drop ding to there. Let's now press play. And we'll head over to the object itself and collect it. So there's our collectible. Now I said I was going to do a couple of different things to illustrate things here, and what I want to really make a point of saying is we did this on trigger enter, and this is important because if we had not set our gem as a trigger, this would not work. All that would happen is that we would walk into the gem and would not be able to pass through the gem. We'd kind of get stuck. So we'd stop, like so. That's why this needs to be set as a trigger. And at this point, because it's a collectible, you can say, I don't know, let's duplicate this, put one there, duplicate this, put one here, duplicate it, put it there, duplicate it, put it here, duplicate it, put it over here. And if you press play now, although it's the same script attached to every object, every single object that is a collectible will now be its own individual entity. Like so. And each one is destroyed. However, when we stop playing, they are reappearing. So that's fine. And I guess it doesn't have to be, you know, the way it is. For example, if we select all of these gems and we shrink the size to 0.5, 0.5, 0.5, so they're much smaller. Let's have the ding set as a higher pitch, so 1.2 or 1.3. Let's take this gem, hold Control, press D, bring it over here, and it's the exact same script, but it's going to be different. So if we go to our materials and we hold Control, press D on red, let's have this as green and just change the color to green. And let's attach that to gem 6, which is that one. Helps if I actually put it on the right one, doesn't it? On the mesh, there we go. So now this is green. Let's increase the size of this to 1, 1, 1. So this is a bigger gem. So this is a bigger collectible. And what we can do is we can take ding and we can hold Control, press D to duplicate it, and this will be a deeper ding, so 0.9. So we just need to make sure that gem 6 relates to that deeper ding sound, like so. And press play. And now we can go and collect these red. Oh, thanks, Alexa. So we can go over here, collect these, and we collected the green one as well along the way for some reason. Let me put the green one right at the end over here. Press play. And let's take one final look at our collectibles. So collect them all. There we go. Oh, and there's that rolling down the hill. It nearly got over the bump then. I wonder what would happen if we actually brought the bridge up one more level. Sorry guys, I really wanted to have a quick look. Curiosity has got the better of me. Round about there. Let's press play. I just want to have a look at that. I'm going to collect these collectibles again because I like the sound of it. Hey, there we go. Ding. What happens with this then? Go on, keep rolling. Keep rolling, rolling, rolling. Cool. He's still rolling. Is he going to hit something? Going to hit the fence? Hey. Anyway, so let me briefly explain what Raycast is, what it can be used for, and why it's useful. Raycasting will cast out an imaginary beam in front of whatever it is attached to. So it could be, for example, your player. It will then tell you just how far away whatever object you're looking at is. So, as an example, our player is looking when it starts at this wall or this fence. The Raycast will return a numerical value of how far away you are. Why is this useful? Well, let's say if you want to walk along somewhere, you want to open a door, but you don't actually know, or the game doesn't know, just how far away that door is. And you want to be able to detect how far away it is before you would display something on your screen to say, for example, open door. And that is all done via Raycasting. It's not a complicated thing, but once you've got a Raycast set up in your game, you can reuse it multiple times and actually have it feed back information regularly to pretty much any script. How do we get this set up? Well, there is one simple thing that we need to do, and that is a script. Yes, it's all done via C# programming. So let's go to our scripts down here. Let's right click, create a new script, and we'll call this, just call it Raycasting, if I can spell correctly. And let's open that up in Visual Studio. Once we're in here, we can get rid of the start method because it isn't required, and we don't need any of the annotations, so we can delete those. We do, however, need to declare a couple of variables. The first variable is going to be a float, and as I mentioned previously, that is a decimal value. Because we can determine how far away something is to a decimal value, it does have to be a float. Now, up to this point, we have used mostly a serialized field to declare a variable. This time we're doing something a little bit different. We are going to have this as a public variable, and we're also going to have it as static. Now, the reason that we make something public and static is so as that other scripts within your game can access information and exchange something like a variable between it. In this case, what we want to do is we want to be able to have the Raycast create a number, but also have other scripts reference that particular number. So as another script, say a door for example, can tell how far away you are from it. So now we have public, static, and we'll have it as a float. And we can call it anything relevant. So we'll say distance from target. with a semicolon. The idea here being, how far are we from our target, or what are we looking at? Now, because this is a static variable, we're not going to be able to see this value in our inspector panel. And for testing purposes at this point, we do want to be able to see it. So what we do need to say down here is serialize field in square brackets. Have this also as a float. And I'm just going to call this something like to target semicolon. So this toTarget variable is simply going to be the internal version of this public static float distance from target, i.e. we'll be able to see this value in our inspector panel, so we just have to make this value always equal to this value. So how do we create this raycast? Well, firstly, let's go into void update. So in the update method, we need to say another variable here. And this one doesn't need to be serialized. It doesn't need to be public. Much in the same way as we did with the starter script. We had this variable here, the integer, my other number. We can do the same thing. Now, we've declared variables outside of methods. However, you can still declare variables inside methods. So we'll do that here as a good example. We'll say raycast hit. And then we can call it anything we want. Because it's a hit, we'll just call it hit. Something really, really simple. So that means that we're saying, well, what is the value of this? So we can say if physics, and you can see it's already trying to predict what we're writing here. So physics.raycast, and in brackets, we need to say transform.position, because this is basically the way of shooting out this imaginary beam that we have, comma, and then we need to basically tell it which direction. So the direction we want this to go in is going to be forwards. So we can say transform direction, and after that we can say in brackets basically which way. Like I said, we want it to be forward, so we can say vector3 dot forward, close bracket, comma is next, and then you can see it's already predicting what we're writing. Out means output, i.e. where are we going to output this information? It's going to be hit. So after that we can close bracket, open curly bracket, hit return. So what is happening here is every frame that this raycast is running, it's obtaining information from the forward direction and it's putting out a number into hit. We can then take that information and put it into both of these variables. So we can say toTarget is equal to hit.distance, semicolon. So now we can see what that value is going to be inside the inspector panel, and we also need to make it in the public static version as well. So we can say distance from target equals hit.distance, semicolon, and save. So this script, although is very short, may appear a bit daunting because of how it's presented in terms of what is actually happening in the if statement. Because up till now, the if statements we've done have always been if such and such is equal to true and something equals true, then do this. This, on the other hand, is doing something differently. It's saying if the raycast is being shot out, return the value in hit, and then make these two variables the same value as whatever hit is. So now let's head back into Unity, give it a moment just to compile. And when it's done that, we need to attach the raycasting script onto, well, it can be attached onto anything, but most of the time it's going to be onto the player. For example, if we were to attach it onto the wall, it would still cast out a raycast, but it wouldn't do anything. It needs to be on whatever object moves the most, i.e. it would be the player capsule. So let's drag and drop raycasting onto player capsule. And if we scroll down, we can see that the only variable we have now is toTarget. Remember I said that public, static, float, distance from target won't appear? Well, there we go, it doesn't appear. It does obviously still exist in the script, but it doesn't appear here. Now let's test out this player capsule with the raycasting on, and let's actually make sure that we can see a value. So if we have player capsule selected, make sure that we scroll down here, and we can see already that as I move around, you can see how far away we are from something. So let's look at this wall. And if you look in the bottom right of my screen where it says 7.549325, if we move closer to the wall, it will decrease. So it will tell you just how close we are to an object. Right up to it, you can see that we are just right next to it. So 0.5 appears to be the lowest it can get to, but that's fine. That's about right, because we're literally right up against the wall, but we're not right against the wall because the player obviously has some limitations in terms of the physics, so that's fine. So we can now determine that 0.5 is about roughly where we are to get close enough to an item. And if we look at the ground, it's not going to really work in the same way, simply because the player capsule itself is the raycast, so it's always casting outward. It's not casting anything else. So if we go this way and look at the wall, there we go. You could theoretically change what the raycast goes on to. So for example, if you put it on the camera route, it would work a different way as well. So let's try putting it on the camera route. You can have multiple raycasts in your game if you want to. It's entirely up to you. It's not important, it's not vital, it's not going to be too draining on resources or anything, but it will give you a good indication of how you can use raycast and where you would want to use it. So on camera route, you can see that if we look at the ground, we're currently 1.46 away from the ground. As we look up further, go to the wall, we're still roughly about the same distance away. So if you want to be able to tell the difference between the ground and where you are now, then yes, have this on the player camera route. If it doesn't matter too much, then I guess it doesn't matter at all. Let's push this ball over here. You could have it just on the player capsule. I think I'm going to keep it on the camera route. That's where I'm going to keep it. Cool. So raycasting, as I mentioned, is vital in pretty much any game. Let me remove it from the player capsule. There we go. So basically to detect how far you are away from things, you know, whether it is an enemy, whether it is a door, whether it is a collectible or whatever, it is important to that extent. So what I want to do here is I want to bring in another game object, place it over here somewhere maybe, and this will be like a treasure chest that we can open. So firstly, let's import that object. Let's go to our objects folder right here and drag and drop this treasure chest into Unity. And as always, head to the pinned comment or the description and you can download this for free. Just remember to unzip it before you try importing it into Unity. So in the folder, we have two objects. We have this one, which is an object, and this one, which is a prefab. Let's drag and drop the prefab into our game right here. Let's rotate it. In fact, should we rotate it? Let me zoom in. Let me have a look at it first. Yeah, let's rotate by 90 degrees. So minus 90. That looks okay. Now, this object itself has a couple of different ways to be set up. If we look at top swing and rotate on the Y, you can do that, which indicates that logically we should be able to do that on the X. So we can open that treasure chest. So how do we do all this? Well, we need to be able to have the actual raycast know that there's a treasure chest up ahead. And it does look a little bit big, but that's fine. What we'll do is we'll put in an object which can be in place of this treasure chest. So having a cube would be quite relevant in this case. So let's go to Game Object, let's go to 3D Object, and let's go to Cube. And let's place this cube roughly where the treasure chest is, and let's increase the size of it to roughly the size of the treasure chest, probably a little bit bigger than the thing, maybe around about there. That should do the trick. And let's turn off the mesh renderer. Next thing, what we need to do is on top swing, we need to add a animation to it so it swings open. So let's go to our animations folder. Make sure we are on top swing. In fact, should we unpack the prefab first? Let's unpack it just in case. So let's right click, prefab, and unpack completely. back on top swing, onto animation, click create, and we'll put open chest. And again, this section will show you just how much everything you've learned can come together to create different effects. So let's press the record button, and we're doing this on the X, so let's make sure we set it to 1. You may need to type 1 and then type 0 just to set that first keyframe. So over the course of a second, which is 60 frames, I want it to open to about there. So press record, head back to project, set the open chest as not loop time, head to the chest itself, the top swing, and go to the controller. We need to right click, create a new empty state, and then right click and set that as default. And we've done all this before, so we know why that's the case, why we need to do that. Let's press play and quickly check that the treasure chest will register as not opening, and we should be able to make sure that our actual raycast will hit it. So let's go to our player route. We can see there's our 2 target. So we're walking over to this massive chest and we're right in front of it. Excellent. So now what we need to do is, if raycast is whatever amount, then we do the following, i.e. open it up, play that animation. So let's go to the scripts folder. Let's right click, create a new script, and we'll say open chest. So in this script, what we'll do is we'll start by just simply saying if the raycast is a small amount, then just open the treasure chest. So if we go and get rid of void start, void update, we don't need them at the moment. Let's declare a variable, so serialize field. And let's have this as a float, and we'll call this internal distance. And now think about it, we probably shouldn't have got rid of the update method, but it's fine. We can retype void update, open close bracket, open curly bracket, and it doesn't need to be private, so that's fine. And what we'll say is internal distance is equal to raycasting dot distance from target, semicolon. So what we've done here is we've said that this script, the open chest script, is reading information from another script. And that's why this has to be a static variable, so as open chest can read that information. Next thing we need to do is we need to add in another variable to say, are we opening the chest? So we can say serialize field, and we'll have this as a bool, and then we'll call it chest open, and we'll make it equal to false by default just in case. So what we'll do now is here in void update we can say if chest open is equal to false and internal distance is less than, should we say 2? I think 2 should be a good number. Close bracket, open curly bracket. First things first, we need to set chest open as true, just so as we cannot repeat this over and over. Next thing, let's add the chest as an actual variable. So serialize field in square brackets, and this will be a game object, and we will indeed have this as chest. It's predicting exactly what we're doing here, and that's really, really clever. It helps you code better. Now we'll say chest dot get component, and we've done all this before. Animator, open close bracket, dot play, and then in brackets and quotes, the name of that animation that we opened with the chest. So let's go to animations. Let's click on the animation, copy the name, head back to our script, close bracket, semicolon, and save. Now, this is not the ultimate final way that we're going to be able to interact with this. I just kind of want to put this in place and see what effects we have. So we now need to attach this particular script to the cube that we put in place of the chest. Give it a moment just to compile. And if we scroll down to our cube and find the script that we just wrote, which is open chest, drag and drop onto the cube. And I'm going to rename this cube to chest trigger. And let's now add the chest as a game object. So basically we're adding top swing because that is the swinging motion. That is the object that has the swinging motion for our chest. Now let's press play. And let's go and take a look. And it's already opened. So the reason that this has happened is simply because there is no trigger on there to determine what we're actually looking at. Now, what I will do here is I will change my direction of my player just so as we can actually see this a little better. Let's put this as 90 degrees. Press play once again. And this is how interaction can actually occur. Okay, so it's saying that the chest actually opened. Let's double check why the chest opened. So it does think, so internal distance is that. So let's press play once again and see what the internal distance comes back at without moving the mouse. And it didn't want to. Okay. Right. What I'm going to do then is, rather than let this make a fool of me, let's actually move the capsule over here a little bit and see what that looks like in game view. Let me turn off the fade in. And let's press play and see what happens now. I suspect it may do the same thing. Yeah. So let's now add some extra lines of code so that this can only happen when we look at the chest and when we press E, should we say. So where we've got if chest open equals false, which it will be, and the internal distance is less than 2, then chest open is true. So now, before chest open is true, we say if, and then input dot get key down, and in brackets key code dot e, close bracket, open curly bracket, delete this close curly bracket, and then where we've got open chest, hit return, and then open curly bracket, close curly bracket. And what that does is we've now nested a couple of if statements. We're saying that if chest is open is false and the internal distance is less than 2, then check if we are pressing the E key to open it. And this is where the true interaction of a game object will occur. So let's save, head back into Unity. And when it's compiled, let's press play. It's taking just a moment to compile there, but that's fine. And press play. We do have an error at the bottom, so we'll have a quick look at that in a moment. So the chest is not opening, so let's take this opportunity to go on the chest trigger, scroll down, and take a look at these numbers here. So we're now less than 2, so let's press E. And there we go. We now have the chest opening. Let's get rid of that. It's not an important error. So one more time, let's make sure that this works. So it's all good so far. Chest is there. We can still go and collect some of these. Perfect. Now let's go and open this chest. E. Perfect. So there are many different ways that you can create a script to interact with objects, and there's more refined ways that you probably should create as well. But as this is only just an introduction to Unity 6 on the whole, this is where you would kind of go a little bit deeper, work with this script a bit more, and create more abilities to do things and interact with objects differently. For example, if you wanted to interact with the ball that rolls down here, you wanted to pick it up maybe, you'd use the same principle. You'd use Raycast and then pressing the E key or R key or whatever to pick something up. So next time what we'll do is I want to create something where it will follow a path. So we'll do a little bit of introductory path following. So we'll create a script that will allow a cube to follow a certain path, maybe in a circle, or maybe it'll go from one end of the map to the other repeatedly. But we'll be setting an object route. So the idea of what we're going to do here is we're going to have a simple cube, but you could pretend that this is an NPC or some monster or something, and we'll allow it to follow a certain path around this map. There are bigger and better ways of doing it. For example, you would use nav mesh, which is a little bit more advanced. But at this point, as this is a beginner series, nav mesh is not too important. I do teach nav mesh in other tutorial series on my channel, and once you're ready to move on to those tutorial series, then you'll naturally learn about that even more. So what I'm going to do is have a cube set just over here, which is going to represent an NPC. So 3D object, cube. I'm going to have this cube as 3 tall, 0.5 thin, and in fact, no, I'll just keep it as 1 by 1 by 3. So let's put this back onto the ground. We'll have this as 2. Let's actually set the position as 0, 0, and then move it into a better position. So somewhere here. Perfect. So now what we'll do is we'll write a script that will allow this cube to move around of its own free will following a certain path. Let's go to our scripts folder. Let's right click, create a new script. And we'll put this as path follow. And open that up in Visual Studio. Again, if you have any problems with this script, it'll be in the pinned comments. You can go there, click the link, and you can download it for free. Now, the object of this will be to define a certain position in the game world itself. And we'll also need to basically set an object for a destination, but we'll get around to that momentarily. All we need to do is say, in the class itself, serialize field, and this will be an integer, and this will be the X position. So X pos and semicolon. Next line will be the Z pos, so serialize field and integer, and rather than predicting Z, it's actually predicted Y, which is fine. We don't need the Y. Next thing will be a game object, so serialize field. And this will be the destination of where the cube will be moving to. So it will be a game object, destination, semicolon. And the final one we'll have as serialize field. And this one will just be a position. So we'll have this as int, and then position equals 1. So this one may not be 100% relative at the moment, but we'll move forward with this. The idea being the whole thing is going to be used as a coroutine, so we can piece it together using that. So the start method is going to basically say that the destination is going to be at a certain point. So what that basically means is that moving the actual destination object to whatever position we would want. So let's start by saying our cube wants to move to somewhere here. So let's create that destination object. Game object, 3D object, cube. Let's bring it down to the ground. So let's have it as 1, 1, 1. And let's move it over here. So this is going to be the first place that it will move to. So 22, 1, negative 6. So back to here, we'll say destination dot transform dot position, because we want to tell it where it's going to, equals new vector 3, and then the position. So we can use the X position, the Y position, and the Z position. So we can say X pos, comma, 1, comma, Z pos, close bracket, semicolon. Now that does mean that we need to set the initial place for this cube. So that is 22 and negative 6. So we set that up here. So xpos is equal to 22. Zpos is equal to negative 6. So wherever the cube is, whenever we start this, that destination cube, it will move to this position, i.e. the position it is now. And that means that the position should be changed to 2. So this is position 1. So we can say position plus equals 1, semicolon. If I can spell position right. So next thing we need to do is create a coroutine. And the coroutine is going to be the next location. And what we'll do is we'll make it so as the cube can move between a couple of different destinations. So this will always be the first destination. So down below here, below update, we'll say I enumerator, and we'll call it next destination, open close bracket, open curly bracket. If I can spell I enumerator right. I really can't spell it. Why am I not typing that right? There we go. So I enumerator next destination. And generally what we need to do here is say yield return new, wait for seconds, and we'll have this as 1, semicolon. And I don't know what I've done wrong here. I must have mistyped it. Let me try again. I enumerator next destination. There we go. Open close bracket, and there's our curly bracket. So after 1 second, what we'll do is, in fact, no, we'll change that to 3 seconds, just to give it a little bit more time. And we now need to set the X position and Y position as something different. Sorry, X and Z. So let's take our cube and let's move it to here. So 16 and negative 6. So X pos equals 16, semicolon. Z pos equals negative 6. I think that's what it was, wasn't it? 16, negative 6. Yes. So before all that, we need to say if, and in brackets, position equals 1, then that's when we open curly bracket and do those 3 lines of code. If I can type it correctly. There we go. So it's saying that if position is equal to 2, I should say, apologies, which it will be after this one, then it means that it moves to here. So we now need to say this line of code once again. So after 3 seconds, it changes the position and moves it, and then sets the position number as +1 once again. Perfect. That does mean that after this first position change to 1, we now need to set the coroutine started. So start coroutine, and in brackets, next destination, open close bracket, semicolon. Now that means, so we've got our first and second position all in place. So let's copy these right here, and let's go below here and say if position is 3, which it will be after here, then wait for 3 more seconds, and let's move the position of the destination once again. Let's move it to here. So 20 and 0. So 20 and 0. And after the third time, let's set the position back to 1. So now we need to set the original position back up, so we can copy that, place it at the top, and say if position is equal to 1, then we set the original position, which is 22 and negative 6. So 22 and negative 6. So what's happening here is that we are repeating this process over and over and over. And what it essentially means is that it's repeating that path. But in order to do that, there's more that has to actually be placed in here. And in the update method, this is where we need to put the actual cube to be moving. So we can say transform dot look at, and in brackets, destination dot transform. So it always looks where it's going. Next, we need to actually move this object. So we can say transform dot position. I really have trouble spelling position, don't I? Position equals vector 3, and in brackets we now need to put transform dot position, and then we need to say destination dot transform dot position, comma, and then we'll say something like something really low because it's kind of speed based, so 0.05f, and then we can trial this out, semicolon. So let's make sure that all of this is going to work. So it should be vector3 dot move towards, and that should complete at least this section of the script. Let me get rid of the annotations just so we can see this a little clearer. So what we're saying is, when the script starts, we need to set the position of the destination and then add one to the destination and start the coroutine. It then means down here that we move to this position and it will move the destination. It will do it again and again. When it gets back to position 1, that's where we could theoretically repeat this process. But for now, let's head back into Unity and let's make sure that we can actually set this up correctly. And what I'm going to do is I'm going to turn off the mesh renderer on the destination, and also going to rename these as well, just so as we know what's what. So on our destination cube, let's turn off mesh renderer. Let's rename this to destination, and we'll just rename cube to NPC. Now let's attach the path follow script to the NPC. And down here we can see we just need to attach destination right there. And let's press play and see how this pans out, at least for now. So there we go. You can see the cube has done that and it's moving all around like that. So the speed looks like it's too fast, but that's fine. Let's change that. Here, let's change this to 0.01. And let's see how that reacts now. When it's done, let's press play. And I think the cube kind of blended into the ground a little bit, but that's something that we can sort out later on. So there we go. It's moving towards that destination. It's moving there. And now it'll move to the other one over there. Let's change this now. So rather than 1 here, this needs to be 2, so as the cube doesn't start going into the ground. That's fine. And ultimately, what we need to do is we need to now set it so as this can essentially repeat itself. So let's add in another variable, serialize field, and we'll have this as a bool, and we'll say, what can we call it? Reset move. By default, we'll just have this as false, but I am going to instantly set it to true. Reset move equals true, semicolon. And in void update, what we'll do down here is we will say if reset move equals false, then do the following. And we can say reset move equals true, start coroutine, and in brackets next destination, close bracket, semicolon. And at the very end, where we set the position back to 1, we can also say reset move equals false, semicolon, and save the script. So what should happen now is we should be able to repeatedly see this cube moving from place to place. And let's actually set this as maybe 2 seconds between each one, just so as we're not wasting too much time. So let's resave the script, head back into Unity, let it compile, and we should be able to see this imaginary NPC follow the path that we have set for him by reaching each destination. So let's press play and take a look. Give it a moment. And we should enter the game view any second. There we go. So now it's moving that way. Now he's moving that way. Now back that way. And now back that way. So you can see that the process is just being repeated until he gets here. So what does that mean? Well, it ultimately means that this has now fallen down. So does it really mean that we need to reset move every time? It probably does. So if we have reset move in each of these, we should be able to repeat that process over and over. So up until this point, we have built this entire very small, simple looking game in one single scene. And we haven't really spoken about scenes too much, but there is a folder called scenes, and there is something called a sample scene. So everything you build inside Unity is inside a scene. And you can think of these as assets as well. So whether you've got a level, whether you've got an open world, or whether you've just got a credit scene or a main menu, it will all be inside a scene. If we go to File at the top, and if we go to Build Profiles, we should be able to see a couple of different things. Now, the main thing to note here is this scene list. And at the moment, there is nothing in this scene list. If you're in an older version of Unity, which hopefully you won't be because this is Unity 6, this window may look a little bit different. You may have build and run and build down the bottom and scenes here up at the top. What you need to do is you need to click on Open Scene List. And this will tell you what the scene list is. And you can then click Add Open Scenes. And here you will see this sample scene that we have built is scene number 0. If you have a game with multiple different scenes, let's say for example 17 different scenes, then the order of the scenes is important. Scene 0 will always be the first scene to load whenever you build your game itself. And although we're not going to go into it in this beginner's introduction, this is basically just a way of determining, that this is relevant. And I do this in my other series, which are slightly more advanced and are probably where you should go to next after this series. So we have the open scene in. So that means whenever we build our game, this scene is going to load and we're going to go straight into our game. So there are a couple of things that we could logically go to first. If you wanted to build this for Android or iOS or whatever platform, you can go here and you can switch platform up here. I'm building this for PC, for Windows, so you can see that mine is active. This is the active build that we are in. You can build for PS4, PS5, if you wanted to, Xbox, all different universal Windows platforms, whatever. However, you do need to acquire a license for publishing to something like PlayStation. Let's close the build profiles for now. And if we go to Edit, and let's look at project settings first. And here you'll have something called Player. There are plenty of options in here, but we don't need to worry about any of them at this point, at least not from a beginner's point of view. This player is all about the standalone application itself rather than the player in the game. So for example, company name can be Jimmy Vegas Game Studios. Product name would be, well, whatever your game is. My Unity 6 game. Version would be whatever version you would want to label this as. So it could be version 1, it could be version 1.1, 1.2, version 2, version 3. Whatever you want. Now we have the ability to select an icon. So we could select a texture that is in our game. So if you've got a texture in your game that is, could be usable for an icon, then absolutely choose it. I'm just going to choose this brick icon because why not? A couple of different options down here. You can have override icons, resolution and presentation. These aren't too important, to be honest. A lot of these are already set as default and are pretty decent in what they are. So don't worry about too much going on here. Different options for different platforms if you need them. The next important one I want to take a look at is quality. And this is where you can have different quality settings for different platforms, depending on what you want to go for. So ultra settings for PC, you can change some of these settings here. But in all fairness, the default settings that you have here are already pretty good and probably don't need changing. Feel free to change them around a little bit, but I think they're pretty good as they are. So player and quality, I would say, are the two things that are important inside project settings. Now, at this point, let's say we want to start playtesting our game and want to see what bugs can occur. Well, this is where we can start building our game itself. To do that, we go to File and back into Build Profiles. Although you don't necessarily have to do that, you could go File, Build and Run. If we go to Windows and go to Build and Run here, now what we do is let's create a new folder. So New Folder, My Game, and let's go into that folder and select folder. Now what Unity will do is it will take all the information that you have put together, all your scripts, all your assets, everything, all your music, and it will compile it into an executable with some data files attached to it. If you've ever played games on somewhere like itch.io or GOG or even Steam, you will have seen some of these files that do exist for Unity. Naturally, Unity is a very, very popular game engine, so it's only obvious that people would use it to create a lot of their games. So it's saying that it has failed. So cannot build player while editor is doing something. Package manager error while getting product update details. Okay, so it doesn't like the fact that I am offline at this point, which is completely fine. So let's try it once again. If we go to File, Build Profiles, and let's build and run, go into My Game, select folder, and let's build this game. So generally, you may come up with a couple of errors which may prevent this from happening. You may need to connect online to receive information and get Unity to do it that way. It's not always the case. I've noticed that whenever I try building something in Unity 6, it doesn't tend to work unless I'm actually connected online, very strangely. Usually I use this machine offline most of the time, but it doesn't really matter. All you would need to do is, if it doesn't work, just get yourself connected, log in with the hub, and then try running once again. Shouldn't have any problems after that. So you can see this is nearly done now. We are getting to the last stages of building. The first time you build a game in Unity 6 will take a little bit longer than every subsequent time, unless your game grows to a massive size. Obviously, the bigger the game, the longer it will take for the build to actually occur. So at this point, we have now built the game, and it should be launching any moment. There we go, made with Unity, and we are straight into our game. So let's wander around and let's have a click. There we go, let's get them. There's that rolling. So already we can see that there are a couple of problems in terms of the text. You can see at the top that new text, that the red one, is gone off screen a little bit. So let's Alt F4, come out of that, and let's have a quick look at bug fixes. So that means us going to our canvas, going to name 2, and just making sure that it is set correctly. Now remember when I spoke about anchoring positions? Well, look at the anchoring position of this right here. This actually needs to be set top right. This button here should really be set bottom left. That's why when we rendered our game there, because we were full screen, this did not look right because it was trying to anchor to a different position. So what we can do now is, now we fix that little bug, let's go to File, let's go to Build and Run, save, and let's see this go a little bit quicker into the build. And we should be able to instantly see the changes in the text on our screen. There we go. Perfect. So it's a case now of playing your game, testing everything out, making sure that everything looks normal, looks sensible, come back into Unity, make your bug fixes, and then rebuild your game. And that's pretty much where we are with this. So where can you go from here? Well, I have plenty of tutorial series on my channel that you can go to, and you can learn many different things, from a first-person shooter to a visual novel to an endless runner to driving games to horror games. And they will take you even further into development, whether it is still with Unity 6 or whether you want to use something earlier, perhaps Unity 22 or 20. It's entirely up to you. But I would recommend going through my tutorials on my channel, seeing if there's anything interesting that tickles your fancy that you would like to have a go at. So I want to thank you so much for sticking with me throughout this entire series. It's been a lot of fun to do. Unity 6 is a great engine to play with. Unity as a company has improved with their engine over the past couple of years, and I do feel like Unity 6 is probably the engine of choice for most people out there who are aspiring developers who want to build their first game. So if there are any questions, please leave them in the comments below. If I don't answer them, somebody in the community will, because there are a lot of great people who hang around my channel, and they are fantastic. They know their stuff. But remember to subscribe and click on that notification bell if you want to stay up to date with every single tutorial that I upload in the future, because there is plenty to always come on my channel. So once again, thank you very much for watching, and I will see you in the next one.